one and all. It's my pleasure to invite our today's chief guest, our beloved HOD, Dr. V. Manjunath Arathya sir, who is currently working as professor and head in the Department of Computer Application, JSS Science and Technology University, Mysore. Sir has also worked as an associate dean, sir is presently also working as an associate dean. Sir has received MSc and PhD degrees in computer science from Mysore University in the year 2004 and 2007 respectively. Sir has received Young Indian Research Scientist from Italian Ministry of Education, University and Research, Italy during 2009 to 10. Awarded with Young Scientist from the Department of Science and Technology in 2009 under Fast Track Scheme. Recently awarded a prestigious ARP Award for Research Publications by Vision Group of Science and Technology, Government of Karnataka for the year 2016-17. His professional recognition includes as a technical editor for journals coverage in information technology, reviewer for IEEE transactions on PAMI, IEEE transaction on system man and cybernetics part B, IEEE access, pattern recognition letters, etc. Sir is also member of program committees over 70 international conferences. His research interest includes pattern recognition and image processing, speech processing, document image analysis, computer vision, machine intelligence, applications on linear algebra for the solutions of engineering problems, biclustral of gene expressions, data and web data analysis and understanding. Sir is currently guiding 4 PhDs and completed 12 PhD students. Sir has published more than 170 research papers in reputed international journals, conference, proceedings, and edited books and citations more than 130. I cordially welcome you to the session.
Good morning to one and all. Hope you can hear me. Yes. First of all, I would like to thank Dr. Arathya for the opportunity, and also thank Professor C.J. Arshita for coordinating this entire Atal FDP program. Today, I'll be dealing with a very immature learning system, the whole of our machine learning and artificial intelligence. That is what I think many of you heard with respect to the one-shot learning and the few-shot learning. So I'll be stressing it both. Like sometimes I can also tell like one-shot learning. In some cases, I also mentioned like few-shot learning, and more perspective with respect to the face recognition task here. Myself, Manjunath Arathya, from the Department of Computer Applications. You can note my email, arathya@sac.ac.in, and of course the phone number. And we are very open, and we also welcome the collaborations with respect to what are the field you do with respect to the machine learning and artificial intelligence. Of course, we also very happy if you want to collaborate with respect to the few-shot learning in future. Let me take my talk in these lines. Very importantly, I'll be talking on the human cognition, which we call it as the concept learning, and we'll go through with respect to a very brief walk I can talk with respect to the few-shot learning or the one-shot learning, and the current motivation and challenges that do exist, especially in this few-shot learning. And I will also touch with some core issues or the learning problems that do exist in few-shot learning, and finally we will see the practical side, something like code I have, and finally we will see how exactly this whole the idea of one-shot learning or the few-shot learning works. Okay. So let me start with this slide. I think many are aware with respect to this problem. So the problem, the idea is that It's a classification problem, of course. You have a couple of images here. And what the key idea here is that each image you have, and finally you have to classify whether it's a male or a female. So it's a very simple task, right? So whichever the image you take, so probably if you take this image, and so machine has to really understand and tell, okay, this could be male, female, female, male, female, or whatever. So now let's take an example. This is my problem, and if I call very young kid, something like age with respect to the 4 years or 5 years. So probably no doubt in no time, so probably what he tells or she tells that, okay, this is male and this is female, and of course this is female, a male component. And finally when you take this sort of sketched images or something like a cartoon images if I call, so probably able to distinguish between the male and the female, right? So you take an example of a 5-year-old or a 6-year-old for that matter. So of course for human, we don't have any problem, it's a trivial process, right? When it comes to a machine, or when it comes to a computer, so probably there is a lot of challenges here. Obviously when you talk about learning, so what is learning is all about finding some model or finding some parameters to whenever you see an unseen data, so probably it has to tell an exact class. That is what the overall idea of what learning is all about. And when you put this to a machine, so probably what machine should understand, and finally it has to classify it is male or a female. Probably there are different algorithms that do exist. I'm not going to touch with respect to all those algorithms or whatever, so how exactly it does, etc., etc. But anyhow, down the last week and also from past 3 days, we have learned like how features have been extracted, how it will be represented, and how exactly it will be mapped, etc., etc. Everything you all know. And finally, you also know with respect to the pattern classification problem, something like you have pre-processing, feature extraction, and classification. And also Shekhar touched upon a deep model where you don't require a pre-processing, directly simply throw an image and finally it understands and finally classify it as a male or a female class. Of course for any machine, so probably in this case it's very hard, right? So whatever the features that do exact, so probably it has to be a very, very meaningful information it has to extract. And finally it has to say it as a male or a female. Okay, let us take an example. So probably, yeah, it has done with respect to some accuracy, 80%, 90% or whatever, so fine. So I go back to the another example. Let's take an example. Let us try to understand that we are meeting for the first time. All meeting for the first time. I come and I say, okay, hi, I'm Manjunath Aradhya, and then I go. Let's assume that I stand for hardly for 3 or 4 seconds. I come and then I say, oh, Manjunath Aradhya, okay, I'll see you later, and then I go. So probably let's assume that one of you will meet me after a week or so, something like that. And finally you have to the beauty of what human cognition comes into picture. The beauty of the human cognition is what? So probably within no time or a fraction of a second, I am able to recognize, oh, you are the guy, right? On that day you came and finally you said hi and then you went, right? Many times that occurs. So probably it all depends upon the individual, but anyhow, no matter time, so probably within some sort of seconds, so probably I will tell, okay, oh, you are that guy, you came then and that day, and you said yes, hi, and then you went. Of course, I can also recognize you, say, okay, you are sitting in the front bench or something like that. That's the beauty of human cognition, right? And very, very important thing is the beauty is something like that, how our mind extracts and how the information stored, everything is, I don't know, blah, 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 right? All neurological processing, etc., etc. We don't know really exactly how exactly these overall things will be happening in our brain, and finally whenever you want to retrieve some sort of information, it will retrieve and finally say some sort of thing like recognition or distinguish between the objects or something like that. all we talk about some temporal sort of thing. That's anyhow, it's more with respect to the cognitive and computation of the cognitive domain. So that is all. Like how humans do? Yeah, you have what sort of tendency, you have that intelligence, and finally you are doing that one. That's fine. So what exactly the human cognition is all about? Do you think that human cognition does a very, very simple task? Very simple task it does? Obviously no. We are not doing anything simple one. Of course, when you talk about what human cognition, obviously you do a very lot of complex things you do, and you perform very complex things. So probably like I just written something like it's something like it includes thinking, it all about the knowing the things, and very, very importantly remembering, judging, and very, very importantly not only solving a problem, of course, what? It's solving a complex problem. So whatever you sense here, you have an information you are getting from the outside world, of course, I receive it. And you have what? The brain, what we call. And so probably you have what bound with these two, like emotions, memories, or something like that. And finally, whatever you got from the outside world, you do it, process it, and finally, the thoughts will be what coming out of with respect to the brain. So this is what a simple structure of a human cognition level. You are sensing it, finally understanding, and finally giving some thought. So probably what outside world, I got an image of Dr. Deepu, and finally my brain recognizes, yes, he is Dr. Deepu, and finally what my thought is, here is Dr. Deepu. So this is how what we normally, the cognition of any human, if you consider, so probably this is how it works. And very importantly, I told very clearly that we don't really do very simple task. Of course, it's a very, very complex one. In day-to-day life, we will be receiving many information or sense, many objects. So probably the processing what we do is obviously what a complex one. Yeah, I will not take much time here. But anyhow, I want something with respect to this one. Why we have to make a machine learning? That's a fundamental question, right? So I heard also what mentioned here, like why we have to learn. Let's forget about that one. Anyhow, we want to solve some problems or etc. Something like that. And finally, what? Now this is where we go. Like why we have to make a machine to learn? Any answers?
To what?
Let us make this session interactive. So probably like let us speak from your side as well. I would like to hear some voices from your side. So
To speed up the task.
okay,
To automate the things.
okay,
To make machine to take decisions.
make machines
Decisions.
decisions. Okay. Yes.
To make machines to do tasks where humans cannot perform.
Okay.
To increase the accuracy.
Okay. Improve the accuracy. Then
To improve the smart city.
huh?
Smart city.
Smart.
Smart cities are better. And the way missions are working.
Okay. So the main purpose of machine learning is what?
Sir,
Is to make the
to
machine.
make the machine learn. So
The
it should
main
make
objective of machine learning and artificial learning. What is that?
without human intervention, it has to
mimic the
automate.
humans.
Very simple. So you have to reduce the effort of human. That's it. That's it, right? Ultimate goal is that one. So 1970s, 80s you go. If you want to withdraw 10 rupees or 20 rupees. So probably if the bank opens at 9 o'clock, the queue probably starts from 7:30 at that time. So everything is manual process. Slowly it entered the era of computers. What happened? Simply you got computer and you had some sort of computers into the picture, and finally you reduce the effort of a human and finally now we are in the stage of probably everything what a machine does, right? And we have a lot of n numbers of what applications with respect to what machine learning. Forget about that. So the fundamental what idea with respect to any machine learning is that what we have to reduce the human effort. That's it. So you take whichever the application and finally it works good. You take banking, it works good. You take camera security, it works good. So probably you keep a guy, security guy, and you want to watch your home, but you fix cameras, and finally you do it. And you can also see hell lot of cameras outside. But in India, whatever the cameras you are seeing, so probably it is not automatic in nature. Everything is simply recording session. That's it. Not intelligent. You go to bank and ATM you go, inside there is a camera, but it's not intelligent. Do you think it is an intelligent one? It's not an intelligent one. Simply it is recording. Whenever you have problem, you go and then you have to see what happened at what time, and finally it does. But there are cases in Western countries where most of the surveillance system is intelligent in nature. So probably you can take many examples like in 2000 something like 17, 18, where that in Bangalore early morning in ATM there was one guy robbed a manager of corporation bank or something like that. Everything was recorded inside the ATM, but the machine was not intelligent enough. Simply it was in the way of recording, and finally the thing is now we wanted if it is intelligent, so probably would have this sort of incidents were never been happened. The key idea of machine learning is, as I mentioned, that you have to reduce the human effort. That's one. When I talk about that one, again at the same time we talk also about the accuracy. At the same time, when you talk about accuracy, we also talk with respect to real time, whether it's a real time. Right? Yesterday Guru sir was mentioning real time. So probably now let's take an example. If something happens at 10 o'clock, 5 minutes and 10 seconds, your system, if it doesn't tell in time instance. What do you mean by time instance? So it happens, let's assume that it happened at 10 hours, 5 minutes, 6 seconds. And if it doesn't respond at 7 seconds or 8 seconds, it's of no use. Right? So probably if it gives you alarm after 2 minutes or 1 minute, obviously it's of no use. We wanted a system, it should really act with respect to the time instance. Time instance is very, very important. Let us forget about what space, etc., etc. We are really not worried about space, because if I throw money, so probably you can buy that one. When you talk about time, so probably you can't buy it. Whatever you do, so probably it is an accuracy at the same time, whether it meets real time or a real instance. That's what the key idea of what machine learning is all about. So I have written something like human expert doesn't. These are some sort of advance. Let's assume that you are in Mars. I want to explore Mars. I can't go there. No human exists there. So probably you come up with a robot. So probably now Mars? What is that robot called? Reservance or what? Robot name?
Mars rover.
Yeah, reservance or something like that. It starts from that. So it is there in the Mars, and finally it is exploring. So human does not explore, and finally when there is no expertise of humans, so probably you have to learn a machine. Humans are enabled to explain their expertise, speech processing. Solutions need to adapt to a particular case, biometrics. So these are some examples which I have given. So probably at the same time we can also list many of that. I will not take much time. Of course, just for the sake of curiosity, I am just telling these are the 3 learning categories. What we have: supervised learning, unsupervised learning, and reinforcement learning. Many of the candidates or many of the scholars or many of the researchers today, so probably they are very good aware with respect to the supervised learning or the unsupervised learning and the reinforcement learning. So this slide I require because when I talk about one-shot learning, so probably I will just match with respect to the same. Okay, I'll just skip this one. So when we talk about supervised learning or an unsupervised learning, very important is the real-time application, where exactly the applications codes good, like real examples. So probably you can take an example of Cortana. In Windows 10 or Windows 11, you have application of Cortana. and that is a speech automated system. You tell, hi Cortana, you just give your speeches, examples you use, and whenever again when you ask, like you open Paint, you open Word, you open PowerPoint, so finally what it acts and finally it opens. It does its job. That is one example of supervised learning. So you train a machine, you train it very well in such a way that I am Aradhya, my voice is something like this, and finally what you do a ad whenever necessary. And also what predicts the winning percentage. These days you can see, you take an example of football, you take an example of whichever the matches with respect to the sports category. Also what, there is something coming like what is the winning percentage of or the winning probability of this team or A team or B team, and finally, of course this is all with respect to supervised learning. Because how it does, so probably you have a past record, it takes, understands, analyzes, and finally gives you the result. Another example could be something like OCR, optical character recognition, converting a scan to what editable form. Spams, I think you all aware, like you have an email and finally what it classifies into spam and non-spams. Very interesting. Of course, artificial intelligence playing inside. There is a intelligent system, so probably whenever the mail comes, it reads, understands, and etc. And finally what tells, okay, this is what spam and this is not a spam. And of course, now recently we also introduced for the messages in our mobile phones. And biometric attendance. All these examples could be real one with respect to the supervised learning. Now let us try to understand with respect to the unsupervised learning. So first example is that party. Let's assume that someone invites me for a party and then I go. I meet strangers. Probably I don't know anyone over there, and finally I go and finally I see hundreds of people there. And everyone strangers for me. So you classify based on the go, right? You go and finally you classify. Let's assume that what I've been invited for this talk, and finally I come. I don't see anyone who knows me, and finally I go and I classify based on what my go, something like that. So probably for this one I can classify into two classes, in a male and female, or I can classify with respect to the what complexion. Or I can classify, it's on my interest, how about like how I have to go or something like that. I want to what, based on those features finally I can classify. All this comes under what, unsupervised learning. You have a data and finally what you have to classify on your need, that's it. That whatever the discoveries that's happening with this outside world is also was unsupervised. Let's assume that you are watching cricket for the first time. Something like golf, you don't know anything, or a football. So probably what, again it comes under unsupervised learning. And you talk about cricket, there is a two person who is holding a bat, and finally what, okay, you classify, okay, these two are one, and rest all other one, or something like that. Okay. So another very interesting is the question, it's trimming down you have a big list, like say like 500,000 or something like that. And finally I have to convert, I have to cut it down to 50 good or 60 good. That is what the key idea of unsupervised learning. So which one you select and which one you not. That's of course what plays a very, very important role. And finally it comes under what? Unsupervised learning. So all this whatever I said, all is all with respect to the fundamental ideas with respect to the what? Machine learning. Now let's move on to the very important concept of concept learning or human cognition. I said this one bit early, like you take a guy of age 6 and we could recognize more than 100 different categories of the objects and keeping you call a guy and you have an object, let's take an example, you place some objects in this what conveyor belt or something like that, and finally what he or she will be able to what classify what saying with respect to, okay, these are similar and these are what not similar. So easily it does, right? When you talk about what this one, very, very importantly, humans. So humans have an ability to learn concepts with very few examples. Not even few. Sometimes it's only with one examples. That is what I gave a bit earlier. Like I come here and then I say hi and then I go out. How many examples? So probably it's only one. You have seen me and then finally, okay, oh, he's the guy. Okay, I went on. And finally, whenever it comes, so probably what you extract what from your what mind and finally say, oh, he's Aradhya. So this is what the tendency what we have, especially with respect to the humans. Humans are very good and they have an ability to learn with very, very few examples. So now the key idea is what? Can I do the same with respect to the machine? That is what the whole idea of few shot learning or the one shot learning. Are you getting? Very simple. Like human hege tendency ಹೇಗಿದೆಯೋ, likewise what? You have to build a machine. That is what the what idea with respect to few shot learning or one shot learning. And when you talk about what this human learning, obviously what you have these three properties. Very important three properties. The first one is the compositionality. Like let's take an example. You have an object and humans can identify its parts and subparts. And let's take an example, you have a what character, something like 4 or something like A. I write A. Right? And easily what humans will be able to what? Understand, okay, you have two slant lines and one horizontal. Right? And these two slant line followed by one horizontal line is what? A. This is what the idea of what compositionality. Humans are very good in what? Understanding with respect to what? Identifying parts and subparts. Right? This is what the idea of what compositionality. Then what do you mean by causality? Causality is something like explaining how new concept can be learned hierarchical from the related concept. How new concept can be learned hierarchically from related concept. So let's take an example. When I write like this, automatically what? You know that you are writing to, right? If I start with something like this, curve followed by somewhere here, and finally what? You'll be very clear like, yeah, he is writing 2. Or if I start with something like this, and finally what? Okay, probably it is 1 or 7, something like that. So causality is what? Something like hierarchy. You are doing, and finally what? When it is connected, finally you will be able to learn. Okay, for the next sequence you will be able to learn what exactly the next point is all about. That is what the idea of causality. Last one is like this one: learning to learn or simply learn to learn. Is called meta learning. This is what a key idea of what? Few shot learning, meta learning. What is meta learning? So, what is that? It refers to the fact that inductive priors while learning a particular task can be shared while learning another task. So, I can give some examples with respect to what meta learning is. My pointer. Sorry. This is where what the key idea of what few shot learning comes into picture. Learning to learn or learn to learn. So let's take an example. I have a robot. What I do, this is what my surface. This is what my surface. I teach my robot that okay, you go here and then etc. etc. You go to that corner etc. etc. Everything I do. I learn robot to simply what? Go in this surface. Which surface? This is a flat surface. Right? And finally, what is my testing? I take that robot and simply I will leave it into uphill surfaces. Uphill surfaces. Are you getting my point? I train in this surface where it is very flat, you don't have any what sort of what obstacles are etc. etc. And finally what? In order to test my what thing, so probably I will just leave it into the uphill surfaces. Now you what? See whether that robot will be able to what climb it and finally reach the destination. That is what the idea of learning to learn. Right? That is what exactly happening with respect to the Mars preservance or whatever so. You don't know the environment. Totally, you have what you made it somewhere like you go there, here, there, etc., etc. But when you put it into some environment, it is unknown. It's totally dynamic in nature. You don't know what next comes. That is what the key idea of what learning to learn. And also, what I can give another example with respect to learn is that learning without a teacher. Learning without a teacher. You don't have any what teacher to what get through with subject, and finally you learn, and finally what you excel. That is what the key idea. Another example of learning to learn. Of course, this learning to learn or meta learning is a very key important what I can say is the key word for our few shot learning. Whole of our what few shot learning works with learning to learn. Right? Okay. Any doubts here? Is it clear? Yes. So this is what the idea of concept learning. Concept learning is really originated from psychology, where it refers to the human ability to learn categories for objects and recognize new instances of those categories. Right? Fine. Yeah. Now let's pitch on to the very unmature area of learning. Very few in this in this world are the researchers have explored with respect to the one-shot learning and the two-shot learning. Very few. And of course, I tell that it's an unmature area in most of our field of applications. And also, another very important is, of course, it's a very quite complex thing, complex to learn and complex to what. We have some sort of what difficulties involved. Anyhow, we will see how exactly we're going to learn this one. Yes.
So that A, like it's like one shot learning, we can identify that it's A.
Yes.
But that's not the case. In the infant, like, we tried for 10 to 20 times, we repeated it, then we analyze, okay, this is A. Now we are able to say that it is a A. It is not like in one go we couldn't identify it as an A.
No. I will come to that point later. I have not touched upon those things. Especially here, like I did explain with respect to the compositionality. What is compositionality? When you talk about concept learning, you have three properties. One is compositionality, causality, and another one is modality. This here, what I mentioned with respect to humans are very good in what understanding parts and subparts. Parts and subparts.
But not in a go.
No, it's not in a go. I am not talking with respect to the go here. I am not talking with respect to the one shot here. So how human tendency or ability against an properties, human ability property, it is classified into three. That is causality, compositionality, and learning to learn. ಅದಷ್ಟೇ ಇಲ್ಲಿ ಇದು ಒನ್ ಲರ್ನಲ್ಲೇ ತಿಳ್ಕೊಬೇಕು ಅನ್ನೋದೇನಿಲ್ಲ. ಈಗ ಈ ಥರ ಕೊಟ್ಟಾಗ ನಾವೇನು ಮಾಡ್ತೀವಿ, ಈಗ ಡಿಸಿಷನ್ ಟ್ರೀ ಎಲ್ಲ ನಾವು ಮಾಡಬೇಕಾದ್ರೆ ಹಂಗೇನೆ ಮಾಡೋದು. ಎರಡು ಸ್ಲಾಂಟ್ ಲೈನು, ಒಂದು ಹಾರಿಸಾಂಟಲ್ ಲೈನ್ ಇದ್ದಾಗ ನಮಗೆ ಟ್ರೀಯಲ್ಲಿ ಸ್ಟಾರ್ಟಿಂಗ್ ಟ್ರೀಯಲ್ಲೇ ನಾವೇನು ಹೇಳ್ತೀವಿ, ಹೇಗೆ ಹೊಂಟೋಗು ಅಂತ ಹೇಳ್ತೀವಿ. ಕೆಳಗೆ ಹೋಗೋದೇ ಇಲ್ಲ, ಬೇರೆ ಬ್ರಾಂಚಸ್ಗೆ ಹೋಗೋದೇ ನೆಸೆಸರಿ ಇರಲ್ಲ. ಆ ಇದರಲ್ಲಿ ಹೇಳ್ತಾರೆ. Likewise, you take what human parts or something like that. You have a part of what face, etc., etc. And of course, you can what also identify subparts of that one. That is what the idea of compositionality. I am not talking anything with respect to one shot.
So then it is fully supervised or semi-supervised?
No. I have not touched anything with respect to supervisors and supervisors. Simply like, see, human tendency, ಈಗ ನಾನು ಒಂದು ಹುಡುಗನ ಕರ್ಕೊಂಡ್ಬಂದ್ಬಿಟ್ಟು ಈ ಪೇಜ್ ಅಂತ ಗೊತ್ತಿರುತ್ತೆ, ಇದು ಮತ್ತೆ ಇದು ಡಿಫ್ರೆಂಟ್ ಅಂತ ಹೇಳುತ್ತೆ ಅಷ್ಟೇ. ಪ್ರಾಪರ್ಟಿ ಅಬಿಲಿಟಿ ಹೇಗಿದೆ, ಹ್ಯೂಮನ್ ಟೆಂಡೆನ್ಸಿದು ಇದು ಡಿಫ್ರೆಂಟ್ ಅಂತ ಹೇಳುತ್ತೆ. ಅದೇ ಎರಡು ಇದು ಕೊಟ್ಟರೆ ಎರಡು ಸೇಮ್ ಅಂತ ಹೇಳೋಂಥ ಕ್ಯಾಟಗರಿ ಇದು ಏನು ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಇದೆ ಹ್ಯೂಮನ್ಗೆ ಅಷ್ಟೇ. ರೈಟ್? ಯಾ. ಸೊ ನೌ ಲೆಟ್ಸ್ ಟೇಕ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ದಿ ಒನ್ ಶಾಟ್ ಲರ್ನಿಂಗ್. ಸೊ ಐ ಟೋಲ್ಡ್ ವೆರಿ ಕ್ಲಿಯರ್ಲಿ, humans have an ability to learn from a single instances. It's something unique to the human species, and one-shot learning algorithms try to mimic this special capability. When you talk about one-shot learning, what I'm trying to do, I'm just mimicking the human mind. That's it. I'm not doing anything else. ಬರೀ ಯಾವ್ದಾದ್ರು ಒಂದು ಫೇಸ್ನ ನಾನು ಸುಮ್ಮನೆ ಒಂದು ಕಾರ್ಡ್ ಏನಾದ್ರು ಒಂದು ಸುಮ್ಮನೆ ಏನಾದ್ರು ಒಂದು ಮೊಬೈಲಲ್ಲೇ ಫೋಟೋ ಒಂಥರ ಇತ್ತು ಅಂತಂದರೆ ಗ್ಯಾಲರಿ ಇದೆ. ಸೊ ಯು ಹ್ಯಾವ್ ಲೈಕ್ 100 ಆಬ್ಜೆಕ್ಟ್ಸ್ ಆರ್ ಸಮಥಿಂಗ್ ಲೈಕ್ ದಟ್. ಸೊ ಇಫ್ ಐ ಶೋ some what images or something like that, I will just show for 2 seconds, I'll just learn and finally it goes. Now the question is that, can I mimic the same thing into my machines? can I learn the same thing, what exactly what happening with respect to the human mind, and I can do it with respect to the machine. That's the question. So that is what the overall idea of what one-shot learning. Okay, so one-shot learning aims to train image classifiers over the data set with only one example, or very few examples per category. You can ask me now. Sir, even Shaker told many other what speakers mentioned when they talked about something like machine learning. You need what hundreds of thousands of etc. What images to what understand and finally give the result. So probably here what you have only what very limited. Let's take an example. I go back to 2020, beginning of March. What is that era? It's all about COVID. We wanted to what do with respect to what COVID classification. We are very eager to what get the images. Very hard at that time to get even what 1 or 2 images. So probably like now understand, the data is very limited. You don't have even 2 or 3 something like samples. If you get it even, so probably what our algorithm or one-shot algorithms helps you classifying what, saying that okay, this is what COVID are. If you give a normal image, so probably you can say so this is normal, right? And likewise, you can say, ask me where exactly you find these sort of applications, especially when you want to deal with respect to one-shot or a few shot. So probably the examples are something like this. Yeah, I will come to that later. Now, what is that one-shot? Fine. You have another variant of that. We call it as few shot or low shot learning. FSL, OSL or FSL. FSL is few shot learning or low shot learning. So learning with limited data. So it is different from standard supervised learning. I will come to that point a little later. And the goal is what? Meta learning. Simple, learning to learn. So you train with some surface and finally you test with a different surface. And you see that whether that application really works. Okay. So you need not to build a model which recognizes the images that train set and generalize the test set. When I talk about friends like few shot learning or one shot learning, you are doing this one, similarity. You are just checking the similarity between objects, whether these 2 objects are similar or these 2 objects are dissimilar. That's it. You are not doing any recognition here. I will give 2 objects, I will give these 2. And system should tell, okay, these 2 are similar, yes. When I give these 2, what system should say that these are dissimilar. That's it. That is what the goal, key idea of what one-shot learning. And everything works with similarity. How similar this object and this object, and how similar and this object and this object. So here we are trying to work with similarity, not anything with respect to recognition. I want to see like how these 2 objects are similar, and I want to see like how these 2 are dissimilar. This is what humans are doing, right? A bottle right? Yeah, so soon when you say bottle, so probably I picked this one, I didn't pick that one. Right? So what humans are so fast in what taking that and finally doing. So probably you learn and you teach a machine in such a way that so probably whatever the human are doing, so probably what the machine has to do. With very few examples. That's the key idea. That's it. Right? And you asked me like, can you just list me some of the limited data applications where you see this one? So probably very importantly with respect to what this one, medical field. Diagnosing development disorders in children. Very rare case. Rare cases are matra iradu. You will not get plenty or hundreds of examples of this one. ಯಾವುದೋ ಒಂದು ಡಿಸೀಸ್ ಇರುತ್ತೆ, ಅದು ಸುಮ್ಮನೆ ಏನು ಲಕ್ಷಕ್ಕೊಬ್ರಿಗೆ ಇರುತ್ತೆ. ಆ ಥರದ್ದಿದ್ದಾಗ ಏನು ನಿಮಗೆ ಎಕ್ಸಾಂಪಲ್ ಸಿಗೋದೇ 1 or 2 ಅಷ್ಟೇ. ರೈಟ್? ಆ್ಯಂಡ್ ಆಟೋನಮಸ್ ಡ್ರೈವಿಂಗ್, law enforcement and forensics, medical field and manufacturing, where you have a very limited data. And finally what? You have to apply and finally understand. All these works with only a few shot learning or a one-shot learning. Obviously if you have n number of data, obviously it's not a what you don't require what one-shot learning or something like few shot learning. Obviously machine traditional machine learning works. Very well. So this is what a motivation, database for learning like human, scarce cases, the reduced data collection effort and competition. Obviously, let's take an example. If your supervisor tells that, okay, you go get of a data, workplace database of hundreds or 200s or something like that. Obviously, you don't require. You tell that I have only 10 samples. Yeah, you work with one-shot learning and finally solve your problem. Right? For one, very important is that it reduces the human effort in collecting the data, and very important, you don't have what cases, rare cases you have diseases or something like that, where the data is very, very limited. As I mentioned, 2020 March, if at all, if you want to get this COVID data, it's very hard, 10 or 20 used to get. So probably based on that, you learn that system, whichever what you comes, you just throw all normal images and then it has to tell, okay, these are normal and these are COVID. So that is what the beauty of one-shot learning. And very importantly, learning like human. I'm very good in learning things, very simple. Even I told like 6-year-old or a 5-year-old can distinguish object with 100 of different or 200 different object categories. This is the prime motivation for me to work towards what? Few-shot learning. Now we'll go with cases. Case 1, case 2 and case 3. And these are like traditional machine learning, how we normally do. Case 1. So you have bunch of phases. I can say that 1, 2, 3, 4. This is a 4-class problem. Let's take an example. You have 4 individuals. If you have 100 individuals, it's a 100-class problem. If you have 1,000, it is a 1,000-class problem. And if you take an example of Aadhaar, what is the class size? What is the class size of Aadhaar? Huh? Yeah, same thing. 1 billion or 130 crores. So that is what the size of what? The class size of what? Aadhaar. Very interesting. Of course, I have couple of examples to what mentioned about the Aadhaar. I will just take it in a different time. So now what you trained, what I do is that I give to the computer and I tell, okay, this guy is all similar. Of course, this guy is the same here, with different shades or different environment. And of course, I have the same guy, some other guy with different shades and environment, and I have another guy with different shapes and environment, etc. Now what? This is what a test case. This test case has not seen during training, right? This is what a traditional machine learning does, right? So what is this? You are throwing this image and finally telling that where it goes. That is what a simple machine learning does. So you take this one, it belongs to here. So probably you can see here. While training, you don't have any features compared to like this. You see here, all are different. Now what you are doing? You are throwing it and finally telling where it goes. And finally, my algorithm is very good, so probably I will say, okay, this guy goes here. Is that simple, right? This is one case. Case 2. Can machine predict the correct one? Of course. You have 2 class with 2 samples and finally somehow able to tell, yeah, is the one. You just understand with respect to what this data and finally I am coming with this data. Reduce the data size. Just train images this much and finally when I train here you have only this many samples. And finally when you throw this one as a test case and finally your algorithm will be able to tell, okay, this, of course I am working with a very good model and finally my algorithm is very strong and finally it tells, okay, this guy, see this guy, okay fine, it is matched. Case 3. What about this? What traditional machine learning does? Can anyone tell me? What traditional machine learning does? What we do, especially when you talk about what machine learning, you have these 2 samples and finally you are giving something. Huh? What we do in the traditional machine learning? Given images will be?
We extract the features.
No, that's fine.
Train it.
That's fine. This is what my training. And finally what I give this test image. And finally what it does?
It
It tries to say respect to the knowledge base. If that is not much,
So simple, what it does, this is what it tries to say, okay, whether it goes here or here, that's it. That's it. because you train two classes and you have two samples, and finally you are giving something which is not in the database, and finally somehow what it tells, okay, this guy or this guy. But actually it is not in the database, it is out of the database. Try to understand. The case study is very, very interesting. What normally we do in what traditional machine learning, because recognition, right? You have a lot of features, etc., etc. You are told, you give something, and finally told, okay, this guy is somehow very similar to this guy, it tells, and finally it ends. Right? This is what traditional machine learning does. What FSL or OSL does this one. See here. Finally, what is FSL? Few shot learning. You have a database here. You have a query. You simply measure the similarity between this guy to this guy, this guy to this guy, and this guy to this guy. You note the similarity. How similar this object to this one? How similar object to this one? How similar object to this one? Right? And finally, what something like you are getting some 0.9. Okay, similarity is near to 1. Okay, fine. This guy belongs to this guy. You said, is that right? So when you take this what cases, you have these three trained, and you are giving this guy. Now what happens? Earlier in the case 3, which I told, you will say, okay, this guy goes here. But obviously here what it tells, the similarity between this object and this object is something like 0.3. The similarity between this to this is 0.05, and the similarity between this is 0.02. You have a maintain a threshold, something like 0.5 or something like that. If it exceeds 0.5, so probably you can say directly that it does not belong to a database. Not in a database. Very simple.
How to set the threshold?
Right?
How to set the threshold?
It all depends upon the team. Like you said for 0.5, it's an empirical method. It's an
Again,
empirical.
same with respect
Obviously,
to
it's an empirical
experimental
method. You can fix any number with respect to ranging from 0 to 1. It can be a 0.5 for the matter. Less than that, you say it's in a database or something like that. If it's greater than that, you tell very clearly it is not out of the database. This is what FSL does. I told you very clearly, it is not with respect to recognition. It is very simple with respect to what similarity. How similar these two objects? How similar this object? How similar is this two objects? That is what one-shot learning or a few-shot learning does. Is that clear? Any doubts? No. Yeah, now what, this slide is very, very important whole to understand with respect to FSL or OSL. Only one slide. This slide gives you some sort of clarity with respect to what you are doing in traditional machine learning, what FSL is. So this is what you do in traditional machine learning. You train the data, etc. Like you have 3 class into 4 samples, 12 samples you train, and finally you give a test case. See here, test samples not seen before. This test is not seen somewhere here. But test samples are from the known class. Right? You know this guy. Yeah, this guy somewhere is in this class. This is what the traditional machine learning does. Right? You train this sample, and when you give test, this test sample is not seen before. Yeah, it is not seen before. But very, very importantly, these test samples are known from the known class. You know where the class coming from. And finally what you do, you test it and finally say, okay, this guy goes here, this is class number 3. That is what the traditional machine learning does. But whereas in what FSL or OSL, see here, you train with a bigger set, entirely different. What do? You train this guy, you train this guy, and you train this guy. But what you do, test is entirely different from unknown classes. It is not there in the database. See here, this guy is not there in the database. Test is from what? Test samples are not seen before, and very, very importantly, test samples are from known class. But what you did, you train with all the samples which belong to one category. While testing, what you are doing is that you are bringing out of the class. And now what you are doing is that you have a very limited support set. Right? Very limited support set.
and finally test the similarity between this guy and this guy and this guy and this guy. If it happens to be what similar, and then tell this guy goes here. That's it. That is what the whole idea of what FSM. If you don't get it, so probably again I will what explain. Yes? Yes, yes. Did you get with this like this? The left hand side is clear, right?
So left hand side is clear, right hand side.
Yeah.
But generally, any of the machine learning application, it aims in either classification or categorization.
Yes.
So here it is as like we are combining both the aspects.
Yeah, again, ma'am, again here we speak respect to what something like recognition accuracy only. But the only thing is that, sorry, but the only thing is that when we test sample, it is not from the database. Unknown class, ಅಷ್ಟೇ ಇದೆ. ಇಲ್ಲಿ ನಾವು ಮಾಡಬೇಕಾದ್ರೆ ಟ್ರೆಡಿಷನ್ ಅಂಡ್ ಮಿಷನ್ ಲರ್ನಿಂಗ್ ಅಲ್ಲಿ ಏನು ಮಾಡ್ತೀವಿ, ಇಷ್ಟೆಲ್ಲ ಇರುತ್ತೆ. ಯಾವುದೋ ಒಂದು ಅನ್ಸೀನ್ ಡೇಟಾನ ಕೊಟ್ಬಿಟ್ಟು ಓಕೆ ಇದು ಈ ಕ್ಲಾಸ್ಗೆ ಹೋಗುತ್ತೆ, ಈ ಕ್ಲಾಸ್ಗೆ ಹೋಗುತ್ತೆ, ಈ ಕ್ಲಾಸ್ಗೆ ಹೋಗುತ್ತೆ ಅಂತ ಅಂದ್ಬಿಟ್ಟು ನಾವು ಅಕ್ಯುರಸಿನ ಹೇಳ್ತೀವಿ. ಬಟ್ ವೇರಸ್ ಇನ್ ವಾಟ್ ಫ್ಯೂ ಶಾರ್ಟ್ ಲರ್ನಿಂಗ್, I train different. Let's take an example. You have 0 to 9 numerals. Numerals 0 to 9 ಇದೆ. ನಾನೇನು ಮಾಡ್ತೀನಿ, 0 to 5 ಟ್ರೈನ್ ಮಾಡ್ತೀನಿ. ಸ್ಯಾಂಪಲ್ಸ್ ಟೆಸ್ಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಏನು ಕೊಡ್ತೀನಿ ಅಂತಂದರೆ, ಇಲ್ಲಿ ಏನು ಟ್ರೈನ್ ಮಾಡಿರಲ್ಲ ಅದನ್ನು ಕೊಡ್ತೀನಿ ಟೆಸ್ಟ್ 9 ವಿತ್ ಫ್ಯೂ ಸಪೋರ್ಟ್ ಸೆಟ್. What is this few support set? If it is a one shot, it is only one sample. If it is a few shot, this is what my support set. Right? Now what you do, if it is a one shot, you compare this sample to this sample. And what system should tell? This system. And if it is a few shot, you have to tell the few samples here, and we compare this to this, this to this, this to this, and this to this. Right? In few shot learning, what we do, we train all different, entirely different. ಇಲ್ಲಿ ನಾನು ಏನು ಅರ್ಥ ಮಾಡಿಸ್ತೀನಿ ಅಂತಂದ್ರೆ 0 0 ಒಂದೇ, 0 4 ಡಿಫ್ರೆಂಟ್, 0 5 ಡಿಫ್ರೆಂಟ್, 1 1 ಸೇಮ್, 2 2 ಸೇಮ್, ಎಕ್ಸೆಟ್ರಾ ಎಕ್ಸೆಟ್ರಾ ಅಂತ ಹೇಳ್ತಾ ಹೋಗ್ತೀನಿ. ಇಲ್ಲಿ ಫ್ಯೂ ಶಾರ್ಟ್ ಲರ್ನಿಂಗ್ ಅಲ್ಲಿ ಏನು ಮಾಡ್ತೀನಿ, ಟೆಸ್ಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಇದರಿಂದ ಕೊಡಲ್ಲ, ಈ ಕ್ಲಾಸಿಂದ ಕೊಡಲ್ಲ, ಸುಮ್ಮನೆ ಅನ್ನೋನ್ ಕ್ಲಾಸ್ ಯಾವುದೋ 6 7 8 9 ಅಲ್ಲಿ 9 ತಗೋತೀನಿ. 9 ಕೊಟ್ಬಿಟ್ಟು ಸಪೋರ್ಟ್ ಸೆಟ್ ಅಲ್ಲಿ ಏನು ಮಾಡ್ತೀನಿ, ಇದನ್ನು ತಗೋಬೋದು ಅಥವಾ ಇಲ್ಲೇ ಯಾವ್ದಾದ್ರು ಒಂದು ಚೂಸ್ ಮಾಡಿಬಿಟ್ಟು 8 ತಪ್ಪು 9 ಕೊಡ್ತೀನಿ. ಸಿಸ್ಟಮ್ ಏನು ಹೇಳಬೇಕು ಅಂತಂದರೆ, ವೆದರ್ ದಿಸ್ ಆ್ಯಂಡ್ ದಿಸ್ ಆರ್ ಸಿಮಿಲರ್, ದಿಸ್ ಆ್ಯಂಡ್ ದಿಸ್ ಆರ್ ಸಿಮಿಲರ್. ಯಾಕೆ ಅಂತಂದರೆ, ನಾನು ಟ್ರೈನ್ ಮಾಡಬೇಕಾದ್ರೆ ಈ ಥರ ಸ್ಯಾಂಪಲ್ಲೇ ನೋಡಿಲ್ಲ ಸಿಸ್ಟಮು, ಲರ್ನ್ ಮಾಡಿರೋದೇನೋ ಇದ್ರ ಮೇಲೆ, ಇದನ್ನ ಇಟ್ಕೊಂಡು ಏನು ಮಾಡೋದು, ಇದು ಮಾಡೋಕ್ಕಾಗುತ್ತಾ ಅನ್ನೋದೇ ಡೆಫಿನೇಷನ್. ವೆರಿ ಸಿಂಪಲ್. ವಾಟ್ ಐ ಡೂ, ಲೆಟ್ಸ್ ಅಸ್ಯೂಮ್ ದಟ್ ಒನ್. ಐ ಕಮ್ ಹಿಯರ್, ಐ have learned these many cases. Let's assume I have learned Bharti ma'am, Madhushri, Shilpa and Shashikala. Right? Now what? New traditional mission learning ಅಲ್ಲಿ ಶಶಿಕಲಾ ಮೇಡಮ್ ಇನ್ನೊಂದು ಫೋಟೋ ಇದ್ರೆ ಶಶಿಕಲಾ ಮೇಡಮ್ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದೀವಿ. ಬಟ್ ಹ್ಯೂಮನ್ ಇದು ಫ್ಯೂ ಶಾರ್ಟ್ ಲರ್ನಿಂಗ್ ಒನ್ ಶಾರ್ಟ್ ಲರ್ನಿಂಗ್ ಅಲ್ಲಿ ಏನಾಗ್ತದೆ ಅಂತ ಹರ್ಷಿಕಾ ಮ್ಯಾಮ್ ಟೆಸ್ಟ್ ಕೊಡ್ತಾ ಇದ್ದಾರೆ. ಸಪೋರ್ಟ್ ಸೆಟ್ ಏನು ಇದಕ್ಕೆ, ಇವ್ರದೊಂದು ಫೋಟೋ ಮತ್ತು ಪ್ರಜ್ಞಾ ಅವ್ರದ್ದು ಫೋಟೋ. ಈಗ ನೀವು ಹರ್ಷಿತಾ ಮ್ಯಾಮ್ ಕೊಟ್ಟಾಗ ಸಪೋರ್ಟ್ ಸೆಟ್ಟಲ್ಲಿ ಏನು ಮಾಡಬೇಕು, ನಾನು ಹರ್ಷಿತಾ ಅವ್ರದ್ದು ಕ್ವೈರಿ ಇದನ್ನು ಹರ್ಷಿತಾ ಮೇಡಮ್ದು ಫೋಟೋ ಇದೆಯಲ್ಲ ನಿಮ್ಮ ಡೇಟಾಬೇಸಲ್ಲಿ ಸಪೋರ್ಟ್ ಸೆಟ್, ಅದನ್ನು ಕಂಪೇರ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ, ದಿಸ್ ಫೇಸ್ ಟು ದಿಸ್ ಫೇಸ್, ಆ್ಯಂಡ್ ಅಗೇನ್ ಐ ವಿಲ್ ಕಂಪೇರ್ ವಿತ್ ದಿಸ್ ಟು ದಿಸ್ ಆ್ಯಂಡ್ ದಿಸ್ ಟು ದಿಸ್, ಆ್ಯಂಡ್ ಫೈನಲಿ ಮೈ ಸಿಸ್ಟಮ್ ಶುಡ್ ಶೋ ದಿಸ್ ಫೇಸ್ ಗೋಸ್ ದಿಸ್ ಮಾಡಲ್.
It is as if we are building another layer of learning.
Another layer of learning. At the same time, ನಾವು ಹ್ಯೂಮನ್ ಹೇಗೆ ರೆಕಗ್ನೈಸ್ ಮಾಡ್ತೀವಿ ಅದೇ ಥರ ವಿತ್ ಅ ವೆರಿ ಸ್ಮಾಲ್ ಸಪೋರ್ಟ್ ಸೆಟ್. ಏನಂತಂದ್ರೆ ನಾನು ನೋಡೇ ಇಲ್ವಲ್ಲ ಸಿಸ್ಟಮಲ್ಲಿ ಟ್ರೈನ್ ಮಾಡಿರೋದು, ನಾನು ನೋಡೇ ಇಲ್ಲ, ಕ್ಯಾಟಗರಿನೇ ಇಲ್ಲ ಅದು. Untrained. Totally. That is what I am telling. COVID example ತಗೊಂಡ್ರೆ ನಾನು ಕೋವಿಡ್ ಅಲ್ಲಿ ಬರೀ 4 ಇಮೇಜ್ ಇದೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳೋಣ. ಈಗ ನನಗೆ ನಾರ್ಮಲ್ ಇಮೇಜಸ್ 100 ಇದೆ. ನಾನು ಟ್ರೈನೇ ಮಾಡಿಲ್ಲ. ನಾನು ಟ್ರೈನ್ ಮಾಡಿರೋದೇನು ನಾರ್ಮಲ್ ಇಮೇಜಸ್. ಕೋವಿಡ್ ಇಮೇಜಸ್ ಬಂದಾಗ ಆ ಸಿಸ್ಟಮ್ ಏನು ಹೇಳಬೇಕು ಅಂತಂದ್ರೆ ಅದನ್ನ ಇದು ನಾರ್ಮಲ್ ಅಲ್ಲ ಅಂತ ಹೇಳಬೇಕು ನನಗೆ. ದಟ್ ಈಸ್ ವಾಟ್ ದಿ ಐಡಿಯಾ ಆಫ್ ವಾಟ್ ಫ್ಯೂ ಶಾಟ್ ಲರ್ನಿಂಗ್ ಅಂದರೆ ಒನ್ ಶಾಟ್ ಲರ್ನಿಂಗ್. You have a deck of what cards. So simply what I'm trying to do is that whether this guy is what similar to this guy, this guy is similar to this anta nota idini. But never what I have seen in my training set. Traditional machine learning ಹೆಂಗಾಗೋದು ಆ ಥರ ವರ್ಕ್ ಆಗುತ್ತೆ. ನೀವು ಟ್ರೈನ್ ಮಾಡಿರ್ತೀರಾ, ನಂದೇ ಒಂದು ಫೋಟೋನ ಈ ಕಡೆ ತಿರುಗಿದ್ರು ಹೇಳುತ್ತೆ ಓ ಇದು ಮಂಜುನಾಥ್ ಆರಾಧ್ಯ ಅಂತ. ಬಟ್ ಇಲ್ಲಿ ನಾನು ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಟ್ರೈನಿಂಗಲ್ಲಿ ನೀವು ಏನಾದ್ರು ಮಾಡ್ಕೊಳ್ಳಿ, ಏನಾದರೂ ಯಾವ್ದಾದ್ರು ಟ್ರೈ ಮಾಡ್ಕೊಳ್ಳಿ, ಫೇಸ್ ಆರು ಮಾಡಿ ಏನಾದ್ರು ಮಾಡಿ, ಟೆಸ್ಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಏನು ಮಾಡ್ತೀನಿ, ಸುಮ್ಮನೆ ಬೇರೆ ಕೊಡ್ತೀನಿ. ಆ ಸಿಸ್ಟಮ್ ನಿಜವಾಗ್ಲೂ ಕೆಪಾಸಿಟಿ ಹೇಗಿದೆ, ಇದು ಇದೇನಾ ಅಂತ ಹೇಳುತ್ತಾ ಅಂತ ನಾನು ಚೆಕ್ ಮಾಡ್ಬೇಕು ಅಷ್ಟೇ.
ಫಾಲ್ಸ್ ಅಕ್ಸೆಪ್ಟೆನ್ಸ್ ಇರಲ್ಲ ಅವಾಗ.
ಫಾಲ್ಸ್ ಅಕ್ಸೆಪ್ಟೆನ್ಸ್
So then what is the use of training?
ಫಾಲ್ಸ್ ಅಕ್ಸೆಪ್ಟೆನ್ಸ್ ಅನ್ನೋ ಕಾನ್ಸೆಪ್ಟ್ ಏನಿಲ್ಲ ನನಗೆ.
ಮಿಷನ್ ಲರ್ನಿಂಗ್ ಅಲ್ಲಿ ಅದು ಯಾವುದೋ ಗ್ರೂಪ್
ಅದು
ಆಗ್ಬಿಡುತ್ತೆ.
ಹೋಯ್ತು, ಅದಾಯ್ತು, ಅದು ನೀವು ಅಕ್ಯುರಸಿ ರೆಕಗ್ನಿಷನ್ ಹೇಳ್ತೀರಾ. ಇಲ್ಲಿ ನಾನು ಏನಂತ ಹೇಳ್ತಾ ಇದ್ದೀನಿ ಅಂದರೆ, ನಾನು 9ನ ಟ್ರೈನೇ ಮಾಡಿಲ್ಲ, ನಾನು ಇನ್ನೊಂದು ಏನೋ ಸಪೋರ್ಟ್ ಸೆಟ್ ಇದೆ, ಯಾವ ಸಪೋರ್ಟ್ ಸೆಟ್ಟು 8 and 9 ಅಂತ ಎಲ್ಲ ಇತ್ತು ಅಂತಂದರೆ ಅದನ್ನ ಕಂಪೇರ್ ಮಾಡಿಬಿಟ್ಟು ಈ 9ಗೆ ಹೋಯ್ತಾ ಅಂತ ನೋಡ್ತಾ
Sir, if
ಇದ್ದೀನಿ.
the support set
What is the use
rather
of
than 9, 8 or
Under
7?
one support set.
So whatever you take, let me take this example. This is my 9th testing. Your support set, you are telling that 8, 1, 7.
Training
What it has to say?
Support set.
What it has to say? Dissimilar. ಅಷ್ಟೇ ಅಷ್ಟೇ ಇರ್ಬೇಕು ನಮಗೆ. ಏನಿಲ್ಲ, ಡಿಸ್ಸಿಮಿಲರ್ ಅಂತ ಹೇಳ್ಬೇಕು. ದಿಸ್ ಇಸ್ ಡಿಸ್ಸಿಮಿಲರ್, 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 ಡಿಸ್ಸಿಮಿಲರ್ ಅಂತ ಹೇಳ್ಬೇಕು. ಎಲ್ಲೋ ಒಂದು ಸಪೋರ್ಟ್ ಸೆಟ್ ಅಲ್ಲಿ 9 ಅಂತ ಇದ್ರೆ ಏನ್ ಹೇಳ್ಬೇಕು? Similar ಅಂತ ಹೇಳ್ಬೇಕು. ಒಂದು ಸ್ಯಾಂಪಲ್ ಇತ್ತು ಅಂತಂದ್ರೆ
Only 8, oh, okay. Oh,
ಎಷ್ಟಾಗಿರ್ಲಿ ಮೇಡಮ್.
sorry.
ಈಗ ನೋಡಿ, ನಿಮ್ಮ ಸಪೋರ್ಟ್ ಸೆಟ್ ಇದರಲ್ಲಿ ಸುಮ್ಮನೆ ಏನು ಮಾಡ್ತೀನಿ, 9, 8, 8 ಅಂತಂದಾಗ ನೀವೇನು ಮಾಡ್ತೀರಾ, ಇದಕ್ಕೆ ಸಿಮಿಲಾರಿಟಿ ಕಂಡಿಡ್ತೀರಾ. ಲೆಸ್ ಸಿಮಿಲರ್, ತುಂಬಾ ಸಿಮಿಲರ್ ಯಾವ್ದು ಬಂತು, ಇಲ್ಲೆಲ್ಲೋ ಒಂದ್ ಕಡೆ ಬಂತು, ಅವಾಗ ಹೇಳ್ತೀರಾ ಸಿಮಿಲರ್ ಅಂತ. ಅದು ಫ್ಯೂ ಶಾಟ್ ಲರ್ನಿಂಗ್ ಅಂತಂದ್ರೆ ಒಂದು ಸಪೋರ್ಟ್ ಸೆಟ್ ಅಲ್ಲಿ ನೀವೇನ್ ಮಾಡ್ತೀರಾ, ಒಂದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಇದ್ರೆ ಫ್ಯೂ ಶಾಟ್ ಲರ್ನಿಂಗ್, ಬರೀ ಒಂದೇ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಇದ್ರೆ ಒನ್ ಶಾಟ್ ಲರ್ನಿಂಗ್ ಅಷ್ಟೇ. Are you getting? So this is what key idea of what one shot learning or few shot learning.
So in few shot learning we don't need any training data.
You require, right?
Why, sir?
You have to learn, right? Otherwise, how you will be able to tell? You train what all these one. You tell the 0, 0, 1, 1, 1, etc. ಅಂತ learn ಮಾಡ್ತೀರಲ್ಲ, ಬೇಕಲ್ವ ನಿಮಗೆ? ನೋಡಿ,
This is only the additional support that we are providing for testing.
see,
Along with the testing.
let's take an example. This group I trained.
So using the training data it will go into
ನೀವು ಯಾವ ತರ ಟ್ರೈನ್ ಮಾಡಿ, ನೀವು ಯಾವ ತರ ಸಿಸ್ಟಮ್ ನ ಡೆವಲಪ್ ಮಾಡಿದ್ದೀರಾ, 0, 0 ಇದು ಎರಡು ಒಂದೇ ಅಂತ ಹೇಳ್ತಾ ಇದ್ಮೇಲೆ 9, 9 ಅಂತ ಇದ್ರೆ ಅದು ಒಂದೇ ಅಂತ ಹೇಳ್ಬೇಕು ನೀವು
So
ಸಿಸ್ಟಮ್.
using that idea.
ಅದೇನೆ ತಾನೇ. ಈಗ ರೀ, ನಾವು ಇವೆರಡೇ ತಿಳ್ಕೊಂಡಿದೀವಿ, ಇವೆರಡೇ ಬಾಟಲ್ ನನಗೆ ಗೊತ್ತಿರೋದು. ಇನ್ನೊಂದು ಯಾವ್ದಾದ್ರು 3ನೇ ಬಾಟ್ಲ್ ಏನಾದ್ರು ಕೊಟ್ರೆ ನಾನು ಇಮಿಡಿಯೇಟ್ ಆಗಿ ಅಥವಾ ಬೇರೆದೇನಾದ್ರು ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಕೊಟ್ರೆ, ಈ ಫೋನ್ ಅಂತ ಕೊಟ್ರೆ ಏನಂತ ಹೇಳ್ಬೇಕು, ಇಟ್ ಇಸ್ ಡಿಸ್ಸಿಮಿಲರ್ ಅಂತ ಹೇಳ್ಬೇಕು ತಾನೆ. ಅಷ್ಟೇ ಐಡಿಯಾ, ಕೆ ಐಡಿಯಾ ಆಫ್ ವಾಟ್ ಫ್ಯೂ ಶಾಟ್ ಲರ್ನಿಂಗ್ ಆರ್ ಒನ್ ಶಾಟ್. Is that clear? So I took around 3 months to learn this overall idea of few shot learning. Every day I used to learn and get confused and then close my books and then I go. This is the only one slide to make you understand what is the difference between traditional supervised learning and a few shot learning. Right? Yeah. So now what? You have variants. Yeah, variants. Okay. K-way N-shot support set. What is that K-way N-shot support set? So this is what 5 class. This is what 5 class. And how many samples for each class? Only one. So then I name it as 5A one-shot. You have 5 classes. Ways are classes. For each class you have samples that is short. So finally, this is 5A one-shot. And this is what you have 5 classes and you have 3 shots. And finally, I call it as 5-way 3-shot. Right? So this is to what get a clarity regarding the classes and samples, K-way and N-shot. Is that clear? Okay. Yeah. So this is what evaluation, like few shot learning is typically measured by its performance on N-shot and K-way task. And these are run as follows, a model, these are not necessary now. Yeah, this is quite interesting. What is the prediction accuracy? As the number of ways increases, accuracy comes down. Is that true? Yesterday, probably what Dinesh or Shekhar sir or Guru sir was mentioning, right? As the number of ways, what is number of ways? Class size increases.
So that is a normal notion of machine learning, no sir? As we
Same
increase the
thing.
number of classes,
Same thing, yeah, that is what I think. At the same time, either way, as the number of shot increases, your accuracy also increases. Right? ನೋಡಿ ಇಲ್ಲಿ ಬರೀ ಒಂದೇ ಒಂದು ಸಪೋರ್ಟ್ ಸೆಟ್, ಅದೇ ಇಲ್ಲೇನು ಮಾಡ್ತಿದ್ದೀನಿ 3 ಸಪೋರ್ಟ್ ಸೆಟ್. ಈ ತರ ಇದ್ದಾಗ ನಿಮ್ಮ ಅಕ್ಯುರೇಸಿ ಜಾಸ್ತಿ ಆಗುತ್ತೆ, ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಹೋಗುತ್ತೆ. As the number of what ways increases, obviously it comes down. Whenever what I am trying to do with respect to machine learning, I should make sure that you have you work for a large number. Working with small like 2 class, 3 class problems, obviously if some algorithm is there and it is giving 100%, I really don't agree with that one. It is not the way of what testing is that in an efficient way. You have to test with a bigger size. Class size should be large. And yesterday Guru sir was mentioning with respect to 99.96 accuracy. What is the error? 0.4. Sorry, 100. Right? Now let's take an example and then I will leave for a break. Let's take an example. This error 0.04. You just understand how important is 0.04 or how important is 99.9999 something like that. I will just mention one simple example. Let's take an example. I told Aadhar, right? What is the size of the Aadhar? 130 crores, right? Let's assume that I had been to watch some vacation to some hill station or something like that. I stranded somewhere. Something happened to me and finally I am in a coma. Right? Now the thing is that using my face and all these fingerprint, can you what? I'll just link with the Aadhaar database. Can you just tell me who is this guy?
Yes.
Yes? Yes? So you are matching with what size? 130 crores. 1 to 130 crores. Because you are not doing verification. Yesterday sir told that you are doing verification. It is 1-to-1 match.
It's just match.
ನೀವು ಬ್ಯಾಂಕ್ಗೆ ಹೋಗ್ಬೇಕಾದ್ರೆ ಆಧಾರ್ ನಂಬರ್ ಕೊಟ್ಟ ಮೇಲೆ ನೀವು ಫಿಂಗರ್ ಕೊಟ್ರಿ ಅಂತ ಹೇಳ್ತಾರೆ, ಅದು 1-to-1 ಮ್ಯಾಚ್. ಆಧಾರ್ ನಂಬರ್ ಕೊಟ್ರಿ ನೀವು ಇದು ನೋಡಿದ್ರೆ yes, it is very very easy, very convenient. But here what? You are got matching with one because you don't any Aadhaar number, you don't have any something like that. You have only face. Let's take different faces. Of course, you take 5 samples. Okay, fine. And you are comparing with 130 crores. If you are what? Recognition accuracy, some model is 99.96, and you are telling 0.04 is what? Your what error? What is the percentage of error with respect to 130 crores of 0.4? What? In terms of lakhs. ಅಂತಂದ್ರೆ ನೀವು ಮಿಸ್ಮ್ಯಾಚ್ ಆಗ್ತಿರೋದೇನೋ ಲ್ಯಾಕ್ಗೆ. Even so, probably this 99.96 is not a good. Even 99.99999999 when you are working with a bigger classes. So you work with a small database of 1,000 or 2,000. What is there? What is fun? Nothing. When you work with this database, obviously what you will see. So this is what actually what
we really want some model or something like that really works with this size and these accuracies. Yeah. Anyway, we'll take a break for tea and then we'll come back to sigmoid function and finally say it is different. Right? Initially, how you label? How you label this one? When you have this one, you will say, let us assume that 0 is similar and 1 is dissimilar. Let's assume. When you have these two, how you label the class? As dissimilar, right? You give 1. Right? And if you have a same, something like 0, 0, and finally you say, okay, this is 0. It's nothing but similar. You have a class labels kodbekalla. Class label kodbekandre, so probably what you have to do, okay, this belongs to dissimilar. And if you have this one, you tell it is a similar one. You train a network in such a way that, and finally you find out the last function or whatever so, and finally find all the weights, etc., etc. Pitch into the testing part. You give a query and tell, okay, where that guy is going, whether it is what, similar or dissimilar. So this is what a Siamese network looks like. So you have an image, you pass it to a network, you find the embeddings, 128, you have again for coming out from this, again it is 128 dimensions, something like that. You find the similarity, nothing but differences, model of the differences, send it to the sigmoid function, and finally say it is a different or similar based on the threshold. That's it. So which are the applications? Computer vision, NLP, robotics, acoustic signal processing, and
Can
So,
we send,
yeah.
can we send analog signal for that?
Ma'am, here, see, I am really not told anything with respect to what type of features, etc., etc. This is where conventional deep learning model is something like CNN or something like that I'm telling you. So now the key idea is that whatever the features you are extracting, so probably all depends upon how good your features are, how good your features is all about. So probably it will tell whether it is similar or dissimilar. That is left to you.
No sir, like in CNN, like
Yeah.
what we'll do, we'll take MFCC feature only for acoustic signal. Like we have a separate feature
ಅದೇ
extraction.
ನಿಮಗೆ ಅದೇ ನಿಮ್ಮ ಅಪ್ಲಿಕೇಶನ್ ಯಾವುದು ಅಂತ ಹೇಳಿದೆ, ನಿಮ್ದು ಏನು ಯಾವುದೋ ಒಂದು ಸಿಗ್ನಲ್ ಅಲ್ಲಿ ಹೇಳ್ತೀರಾ, ತಗೊಂಡು ಮಾಡಿ, ಏನು ತೊಂದರೆ ಇಲ್ಲ. ಮ್ಯಾಮ್ ಇಲ್ಲೇನು ಮಾಡ್ತಿದ್ದೀವಿ ಅಂತಂದ್ರೆ ಈ ಸೈಮೀಸ್ ನೆಟ್ವರ್ಕ್ ಹೇಗಾಗುತ್ತೆ ಅಂತ ವರ್ಕ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಇಟ್ ವರ್ಕ್ಸ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಕನ್ವಲ್ಯೂಷನ್ ನ್ಯೂರಲ್ ನೆಟ್ವರ್ಕ್. Now let's take an example. I don't know anything with respect to convolutional neural network. I have two phase images, so probably I have to extract some sort of features, and I do it, and finally I will take some threshold and finally say, okay, this is different and not different. That is left to you. That is different story. I am not touching anything with respect to that. But Siamese network, how it works? You have these two phases. You send it to a network, convolution neural network for that matter, and find the impedance, and try to get through with the sigmoid function, and finally it will tell based on the threshold, it is a similar or dissimilar. That's it. Okay. And so application lies acoustic. Yeah, I will just show you the code, then for probably what you can understand more. Yeah. Taxonomy is important. Like when you talk about one-shot learning or a few-shot learning, the perspective is with respect to these three: data, model, and algorithm. What is data? And here they are there. So what you take very, very less. ನಿಮ್ಮ ಹತ್ರ ಇರೋದು ಬರೀ 2 ಸ್ಯಾಂಪಲ್. ಇದನ್ನ ನೀವೇನು ಮಾಡಬೇಕು? ಟ್ರೈನಿಂಗಲ್ಲಿ ಏನಿಲ್ಲಲ್ಲ ಡೇಟಾ. You do data augmentation. What is that? You increase this to 100,000 or something. Right? That is with respect to data. Let's assume that we have only 2 samples. But training ಗೆ ನಿಮಗೆ ಏನು ಬೇಕು? ಜಾಸ್ತಿ ಸ್ಯಾಂಪಲ್ಸ್ ಬೇಕು. ಅದನ್ನ ಹೆಂಗೆ ಮಾಡ್ತೀರಾ? ಡೇಟಾ ಆಗ್ಮೆಂಟೇಷನ್ ಅಲ್ಲಿ ಮಾಡ್ತೀರಾ. ಒಂದು ಸ್ಯಾಂಪಲ್ನ 100, 200, 300 ಮಾಡೋಂಥದ್ದು ಆಗ್ಮೆಂಟೇಷನ್. ಒಂದೇ ಒಂದು ಇಮೇಜ್ನ ಡಿಫ್ರೆಂಟ್ ವೇರಿಯೇಷನ್ಸ್ ಅಲ್ಲಿ ತೋರಿಸೋಂಥದ್ದು. That is one point. Second one is with respect to the model. You can either do in this way, or otherwise you can do in this way, or otherwise you can do with respect to the search. Nothing but what algorithms like alter search strategy with hypothesis based by prior knowledge. This hypothesis based, that this and all, I am not telling much what we can see with respect to the core issues. Now, any machine learning again very important is this empirical risk minimization, right? Your risk should be minimum. Alva loss ಕಮ್ಮಿ ಇರಬೇಕು ಯಾವಾಗಲೂ. 100 ಟೆಸ್ಟ್ ಸ್ಯಾಂಪಲ್ ಕೊಟ್ಟರೆ
ನಾನು 100 ಟೆಸ್ಟ್ ಸ್ಯಾಂಪಲ್ ಕೊಟ್ಟರೆ ಯು ಸಿ ಟು ದಟ್ ಯು ಅಟ್ಲೀಸ್ಟ್ 99 will go through. And risk is what? 99 divided by 100. Some 0.12 or something like that. Yeah. 99 divided by 100. That is what your recognition is. You have 100 and finally it is saying 100 and what is the risk? It is 0. All 100 is matching and finally what is your risk? Risk is 0. You see to that whole of our OSL or FSL, this risk is what? Minimum. Whatever the algorithm, whether you work with the data or whether you work with the model or work with the algorithm, that is left to you. Right? And that's fine. Taxonomy. Yeah, these are some references. One-shot learning object. So yeah, this is where we did one-shot cluster-based approach for detection of COVID-19 from chest X-ray images. We did and published in Cognitive Computation in 2020. And another one, not mentioned here. In the same, but this is in a different approach. We took like one sample, only one sample. We trained only one, and then we gave hundreds of test images, and we wanted to see whether our algorithm is really working fine or something like that. See, machine learning. When you talk about machine learning application, when you talk about classes, etc., we can talk hours together. You have that many problems that do exist here and there. You talk about classes, you talk about features, you talk about what samples, you can talk about many other issues there. You have a lot of issues available. As mentioned with respect to the other UTI. See, you have 130 crores of what faces or something like that, and finally what error, even if it is 0.4 error, it is what very, very big one. All those issues are there. So probably what you have to take the exact issue what's there in the application and finally we have to solve it. That's it. Okay. So let us now walk through with respect to the code. This code is available, but anyhow I have little bit modified here and there for my reference. I'm a character recognition guy, and then what I did for characters only, it's not a problem. The same thing holds good for faces or any other images for that matter.
Sir, in that
Yes, ma'am.
chest X-ray paper,
Yeah.
you have used the basic philosophy of clustering, but with few shot learning.
Yeah, no, one shot ಅಂತಂದ್ರೆ ಬರೀ in the overall approach is entirely different from that one. Actually what we did ಅಂತಂದ್ರೆ traditional machine learning ತರನು ಮಾಡಿಲ್ಲ, ಬರೀ ಒಂದೇ ಒಂದು ಸ್ಯಾಂಪಲ್ ನ ಟ್ರೈನ್ ಮಾಡಿಬಿಟ್ಟು ಅದರಿಂದ ಕ್ಲಸ್ಟರ್ ನ ಫಾರ್ಮ್ ಮಾಡ್ತೀವಿ. ಕ್ಲಸ್ಟರ್ ಫಾರ್ಮ್ ಮಾಡಿದ್ಮೇಲೆ ಆ ಕ್ಲಸ್ಟರ್ ನನಗೆ ಬೇಸ್ ಟ್ರೈನ್ ಮಾಡೋದಕ್ಕೆ, ಅದನ್ನ ಇಟ್ಕೊಂಡು ಟೆಸ್ಟಿಂಗ್ ಮಾಡೋದು. ಸೊ ಅಲ್ಲಿ ಈಗ ವೆರಿ ಇದು another core issue in our machine learning is what like just take 1 or 2 minutes here. Where is the tester? Okay. See, normally what happens, ಇದೆಲ್ಲ ಇದು ಅರ್ಥನೂ ಆಗೋದಿಲ್ಲ, ಕಷ್ಟನೇ ಒಂದು ಸ್ವಲ್ಪ, ಯಾವ ತಗೋಬೇಕು ಏನು ಅಂತಲೂ ಗೊತ್ತಿಲ್ಲ. ಲೆಟ್ಸ್ ಟೇಕ್ ಅನ್ ಎಕ್ಸಾಂಪಲ್. ಯು ಹ್ಯಾವ್ ಅ size of training size of 1000 samples. Let's assume. And you have like another 500 for testing. Now the another way, I will go in this way. Totally, let's assume that you have 2000 samples. I'll just don't take this one. Let's assume that this is what my 2000 samples. And what normally we do? ಇದನ್ನ ಎರಡು ಭಾಗ ಮಾಡೋದು. This is training and this is testing. ಸುಮ್ಮನೆ random ಆಗಿ ಸುಮ್ಮನೆ 1500 test and this is what 500 samples. Now the interesting thing is that how do you know that? Let's assume there is an image. When you take this image, what is the guarantee that this image is really performing well on your training sample? And the question, you don't know really. Let's take an example. There are cases like there are images somewhere here, but you are not taking into consideration. But obviously what we do is simply divide into 2 halves. One is training and then one is testing. And there are cases like leave one out, leave out strategy, something like that. That is another case. But normally the question here is that what is the significance of telling that this image is really what helping you much in a training set ಅನ್ನೋದು ಒಂದು ಕ್ವಶನ್. ಅದಕ್ಕೆ ನಾವೇನು ಮಾಡ್ಬೇಕು ಅಂದರೆ ಫಸ್ಟ್ ಒಂದು ಇಮೇಜ್ ತಗೊಂಡು ಇನ್ನು ಮಿಕ್ಕಿದೆಲ್ಲ ಇನ್ನೊಂದು ಕ್ಲಾಸಲ್ಲಿ ಇದೆಯಲ್ಲ ಟೆಸ್ಟಿಂಗು ಅದ್ರ ಜೊತೆ ಕಂಪೇರ್ ಮಾಡಿಬಿಟ್ಟು ಈ ಇಮೇಜ್ ನಾನು ಟ್ರೈನಿಂಗ್ ತಗೊಂಡ್ರೆ ಸೊ ವಾಟ್ ಈಸ್ ದಿ ರೆಕಗ್ನಿಷನ್ ಅಕ್ಯುರಸಿ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ದಿಸ್ ಟೆಸ್ಟ್ ಅಂತ ಟೆಸ್ಟ್ ಮಾಡಿ ಅದೇ ಥರ ಒಂದು ಕ್ಲಾಸಲ್ಲಿ ಲೆಟ್ಸ್ ಅಸ್ಯೂಮ್ ದಟ್ ಇನ್ ಕ್ಲಾಸ್ ಸೊ ಪ್ರಾಬ್ಲಿ ಲೆಟ್ಸ್ ಯು ಹ್ಯಾವ್ 50 ಸ್ಯಾಂಪಲ್ಸ್ ಅಂತಂದರೆ I did identify which sample is very good and performing well in my training sample ಅನ್ನೋದು that's one shot learning concept. And then I selected, I clustered around 4 or 5 in this class, and again 3 or 4 in this class, 3 or 4 in this class, and finally I will make around 20 images for my training, and then I will be testing with 10,000 and 1 lakh or something. These 20 are more sufficient to whatever the test case unseen enable is 20 sample. That is what the whole idea of what one shot clustering what I did there. So ನಾವೇನು ಮಾಡ್ತೀವಿ ಅಂದರೆ ಪ್ರತಿಯೊಂದು ಇಮೇಜ್ ತಗೊಂಡು ಈ ಟೆಸ್ಟ್ ಅದರ್ ಇದರಲ್ಲಿ ಹೇಗೆ ಪರ್ಫಾರ್ಮ್ ಆಗುತ್ತೆ ಅನ್ನೋದನ್ನ ನೋಡೋದು ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಸೊ ದಿಸ್ ಲೈಕ್ ದಿಸ್ ಯು ಹ್ಯಾವ್ n number of problems that do exist in what machine learning. But only thing is that there are some issues and finally we have to see and then what we have to work. Okay, that is one thing. So coming to this code, I will not go in detail, but anyhow, if you have any doubts or problem, what you can contact me. Hope you can able to see this one, but in detail not necessary. It's okay. I just make this a little bit. Okay. So I'm just taking from the GitHub database, directly downloading. So something like yeah, I'll show you once I download. Yeah, it's downloaded. And you can see the database here. Yeah. Actually, what this is a 50 characters we have, different languages. So something coming from Balinese, Bengal, Cyclic, Greek, Gujarati, Hebrew or something like that. Okay, you have totally around 50. Out of that, what I do is that I select 30 for my training. The rest 20 I will use for testing purpose. Are you getting my point? So what I am trying to do is that, let's assume that you have 0 to 9, 10 class. 0 to 5 I train. All these sets I just use for training. Here Malayalam is not there. I will use Malayalam for my test. That's somewhere like 6 is my Malayalam. And all other training, whatever the languages you do it. That is what I said, right? Yes. So now what? In order to make things very similar to what face recognition, I have Bengali, nothing but face images. You have around 46 guys. Let's assume there are 46 guys in my face database. Each guy has got around these many variations. Just a very similar character to face, right? You have 46 persons. Each person have 20 different faces. Likewise, I am just doing. So now what I am doing is that I train only Bengali. And then what I test? I test Malayalam. Is that clear? Are you getting my point? What I do, let's assume that these people are Bengali and these people are Malayalam. I train only Bengali people. For testing, I choose from Malayalam. And now what I will see, like how exactly what the system is performing with what Malayalam, which is not in my training data set. Right? Okay. So, okay, I just close this. I will go to this mail. And yeah, this is also what you can take this one. For the simply what batch size is 10. I think you all know with respect to what you mean by batch size or something like that. I'm just showing you like how I paired the images. Yeah. See, this is what the images is telling. Okay. I have taken from Bengali. I have taken this and this one. It is saying that dissimilar. It is a dissimilar, right? You have to give the name. If it is dissimilar, I will give 1. If it is similar, I will say it is 0. Okay, this is similar. I give 0. This is dissimilar. I give 1. Likewise. I simply want taken from the database for the sake of what visualization. Something like this how what? You have to pair the images. ನಾನು ನೋಡಿದ್ನಲ್ಲ ತೋರಿಸಿದ್ನಲ್ಲ ಸೈನಿಸ್ ನೆಟ್ವರ್ಕ್ ಅಲ್ಲಿ ಪೇರ್ ಮಾಡಬೇಕಲ್ಲ ಅದೇ ಥರ ಇಲ್ಲಿ ಪ್ರತಿಯೊಂದು ಪೇರ್ನ ತಗೋಬೇಕು ಟ್ರೈನ್ ಮಾಡಬೇಕು ಸಿಸ್ಟಮಲ್ಲಿ ಇಡಬೇಕು ಆ್ಯಂಡ್ ಫೈನಲಿ ವಾಟ್ you know what is this is dissimilar, it is 1 and what ನೀವು weights ಎಲ್ಲ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಎಲ್ಲ ಮಾಡಿದ್ಮೇಲೆ ಸಿಸ್ಟಮ್ ಏನಾಗಬೇಕು ಇದು 1 ಅಂತ ಹೇಳಬೇಕು ಇದೇನು 0 and finally what it has to say it is a 0 likewise. So 1 2 3 4 5 5 5 10 batches I have taken and finally this is how it is. Okay, this is simple, not a problem. And then what all your convolution in neural network comes into picture, this one. What is that? The size of the image is 105 to 105. You do all pooling, convolution, etc., etc. Multiple times also you can do more than one time or something like convolution, max pool or something. That is what the layers you create. I create the layers. Yes. And you create the graph layers for the same. And now what deep learning network? DL network and the inbuilt function is that. What? Use that one. Right? And you create all weights randomly for 4096 embeddings and number of iterations for the sake of what completeness I'm giving 50. Obviously the number of iterations should be more than 10,000 or 20,000. That many times what you have to learn, nothing but epochs, right? There is nothing but epochs here. But for the sake of for simplicity, if you want to see how exactly that loss function is happening another case, just taking number of iterations. And mini batch size is something like 400 I have taken. Right? So learning rate, all these are parameters with respect to deep learning. I am not going in deep. Okay, and yeah, I go till here. Yeah, number of iterations and then the batches. I'll just do it. Okay, now you see the interesting part. Now I am training the network for 50 iterations. Yeah, now the iteration started. And the initial last function will be for 0.6 and then you see how exactly what the network changes and see how it is growing, how the last function is growing, we can see. We will see till what 50 how it goes and finally what we will see. So probably what should be the value of loss function? What should be your loss? 0. 0 ಬರತಕ್ಕ ನೀವೇನು ಮಾಡಬೇಕು? ನೀವು ರಿಪೀಟ್ ಮಾಡಬೇಕು. Epochs are nothing but iterations na ಮಾಡಬೇಕು. So probably it will it all depends upon how you take the images and how you are doing all sort of things, right? And so probably what your expectation that loss should be 0. You make a train in such a way that it reaches 0. So finally you can see here go ups and downs, etc. For 50 iterations, it comes somewhere like, see, for the second iteration, it went to what, 7. Loss is 7. More than 1 actually. Right? It comes down, it goes, etc., and finally went for 50 iterations somewhere it will be 6.
But sir,
Yeah.
this type of plot indicates that the model has not learnt
Not
with
learned very well.
stability.
Not learned very well.
Ah.
Yeah, that's it. So you have to, that is why, like,
Either it is overlearned or it
yeah.
has not learnt it.
yeah, it is not learned. No, but initially it may not learn well.
Yeah.
Initially it may not, that is what I am telling. As the number of iteration goes, probably what it reaches 0, right?
But if it is a stable model, if it
Ah.
has learned from the balanced data set, then you have
ಅದು
to get
ಅದು
a graph,
ಟ್ರೂ
a clear
ಅದು ಟ್ರೂ
graph.
ಅದಕ್ಕೆ ನಾವು ಏನು ಮಾಡ್ತೀವಿ ನ್ಯೂರಲ್ ನೆಟ್ವರ್ಕ್ ಅಲ್ಲಿ ಅದಕ್ಕೆ ನಂಬರ್ ಆಫ್ ಎಫರ್ಟ್ಸ್ ಜಾಸ್ತಿ ಮಾಡ್ಬಿಟ್ಟು ಇಟರೇಷನ್ಸ್ ಜಾಸ್ತಿ ಮಾಡ್ತೀವಿ
Or else you fine tune the
that is what. So initially for the learning rate what I have taken is 0 point somewhere like 0.6 or something like that. So probably if you vary that what learning rate, obviously what your graph also varies.
It should be very much
Oh.
learning.
Yes. Now what you see is earlier it was 7 something like, now it has come to 3 or something like. Finally you will get somewhere like in 50 iteration you will be touched with 1. You go down with 100, 200, 1000, 10,000 and obviously your loss will be somewhere here. Very near to 0.1 or something. It's okay for me. It's okay. 90% you learned very well. That's more than enough, right? You have a page of what? 1 page. You have a 1 page of what document, and finally you know 90% is okay for me. Right? I have done 90% of that one. 10% variation is that it's okay, no problem. I can manage somewhere. That is what the core principle of dimensionality reduction, right? Principal component is what you said. When you transform the data,
From one dimension to
no,
another.
another one. It's nothing but what it says. So when you are in a raw data, obviously you are not seeing well.
Probably.
When I transform to some other space, I am able to see 90% of the data very well. That is what the core idea of what principal component analysis. What you are doing there, very simple. You are calculating eigenvalues and eigenvector. I am not very good in this state. You come somewhere here. You can see me much better compared to what I am there. That is what the idea of what principal component. Same thing holds good here as well. And it goes and goes and finally what you can see some variations with respect. And finally in some 50 iteration what it comes somewhere here and I can stop. Now what why we have to work with deep models, the question. Why we have to work with deep models? When there is a conventional what neural network or something like that, like RBF, generalized regression neural network, probabilistic neural network or something like that. Why people work with deep learning?
Sir, all the statistical learning methods, they require feature engineering.
Yes.
CNN acts as global feature extractor.
Yes.
For that we need to go for deep learning. If you go for
My-
statistical
yeah,
methods,
my question is that, let us forget about all this thing. But my question is that time. It consumes a lot of time, right? The computation, even like if this what they talk about carbon dioxide, that, this and that, you know, like when we talk about deep learning model ನಮಗೆ ಎನ್ವೈರನ್ಮೆಂಟಲ್ ಎಷ್ಟು ಎಫೆಕ್ಟ್ ಅನ್ನೋದು ಒಂದು ಪೇಪರ್ ಇದೆ ಅದನ್ನ. ಇಲ್ಲಿ ಇದ್ರದ್ದು ಹೀಟ್ ಎನರ್ಜಿ ಅದು ಇದು ಏನೇನೋ ಹೇಳುತ್ತೆ. ನೀವು ಕಂಪ್ಯೂಟರ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ, ಅದು ಪವರ್ ಏನು, ಅದ್ರದ್ದು ಏನೇನೋ ಇದೆ. ದಟ್ ಈಸ್ ಡಿಫರೆಂಟ್ ಸ್ಟೋರಿ. ಮೈ ಕ್ವಶನ್ ಇಸ್ see, like why we have to work with deep models? Already what traditional what the neural network model, which also gives a very similar results. One question. So normally blindly what people will do, there is a model, deep learning model, everyone is doing. Let me see. That is one what intention with respect to research. And why? And many times what you have to think under that, like is it really required for your application is the question. As the number of class increases, try to understand. As the number of class increases, let us assume that 1,000, 2,000, 10,000. Obviously, if your neural network doesn't perform, so probably then you can touch with respect to what deep learning. There are cases where you work with 2-class problem or a 10-class problem or a 20-class problem or a 100-class problem. Then why you require really a deep learning model? See, when you talk about neural network, if you really understand the neural network behavior and if you understand with respect to the architecture of RBF or what PNN or generalized real regression neural network, you can do much better compared to what deep learning models work. Even when we work with respect to what I told with COVID, right? I work with PNN, probabilistic neural network. Deep learning models for the date same it was giving 99.9. My algorithm was giving much better than that 100. See, likewise, we have to first question ourselves like why we have to work with deep models. What is the necessity of that one, and finally what to do. Otherwise, simply you have a lot of algorithms, you take it and you run it. One way or the other way, you will get the result. You don't know how exactly it is working, like brain. I don't know how I'm taking your features or something like that. I'm finally keeping. Whenever you come, I can easily tell. I don't know what is that inside. Likewise, here it's something like a black box. Something happening, and finally we have a small size of class, so probably it is giving some result. As the number of classes increases, you just test your algorithm whether really withstand for the large number of classes. That is what the challenge, right? And finally come down. Yeah, see here. It started from here and finally it is somewhere here with the 2. As the what iteration goes, so probably it may come down. That's fine. That's fine for my iteration. Let me test with the Malayalam. Okay, I have done. So what I'm taking Malayalam as a test one. One thing I was getting some error. I don't know whether I get the same, but not a problem. Yeah. Okay, and yeah. So accuracy batch size I'm taking 10, and I'm taking with respect to what pair labels accuracy. I'm just go in what step by step when I take this one. I just let me complete with respect to the accuracy part. Okay, and run it again. Yeah, it's taken. Anyhow, what is the accuracy? Let me see somewhere. I'm working for mini batch size. What is this batch size of 5 I'm doing? 10 with 5. 5 is what pair level images. But anyhow, accuracy. Yeah, accuracy. Yeah, it's something like 0.5 and 0.7. Something like average is 0.5 plus 0.7, 1.2 divided by 2, it is 0.6. 60% accuracy. Okay. So I'll show you what how exactly this pair works. Line by line I go. This one. I'll go with a line by line step. It's already in the database, it's skipping and finally telling it's downloaded is completed. Yeah, IDX, index. So I have given 8. So these are the indexes, and you see the what I showed you the graph, right? So you directly there. Okay. This one. And okay, so this is what you have taken this one example as example. So these are dissimilar, similar, etc. Something like that. And now what? With the model. So do that, graph, make, weight calculation. So number of iteration 50, mini batch size is 100, learning weight is what? Actually 6 into to the power of -1 I have given 0.6. It is on now. Now I have entered into the equation. Now you see. What is the pair labels? Yeah, see here. 100. Batch size is 100. Right. And x1, x2 first one, it is similar. Something like that. And second one is what? 0. It is similar. Again similar, something like that. This is what I have to create. Right? Did you get it? Did you get it? So this is what, like for each batch, you have to create the pairs. Right? Now what? You learn with this and finally iterate many times. Right? So next step, you find out the loss. What is the loss? You can see some number 0.6 initially. Okay, so we can type here what is the loss? 0.69 initial, first iteration, right? And continue doing your answer. And now it goes to the second one. Yes, here. And again what? Get Chinese batch. Now you can see. You have pair labels 100 and for each pair what? You are telling similar, dissimilar, etc. etc. For this set, what your algorithm should learn. Right? Same similar with respect to neural network, what you are doing. That is, you are not doing anything else more or anything else less. Right? And then you do it for 50 times, like 50 times or 100 times, and finally it comes out. And finally what happens? It will learn, it will give the weights. Then come over here, testing. You take the images. You take the images from Malayalam or something like that, and finally see here, the accuracy batch size is 10. Accuracy is nothing but 5 different batches I'm creating. See again what you get the Chinese batch with accuracy batch size with something like 10 different labels you get, and you see to that whether what works or not. Yes. Otherwise, quickly what I can do is that let me run. Ma'am, I have time, right?
Yes,
Another
sir.
5-10 minutes?
Yes, sir.
We'll do one thing. We will take only 10 iteration. Very quickly we will do it. Or if we are all cash, that is it. Quickly what we will do for 10 and then what we will see is for. Yes. Training आता है क्या? Training is very simple. What you do? You do pairs and then you tell, okay, these are similar 0, dissimilar 1. Like that you train the image and you learn very well. Now then what you go for a test case, then you give pair of images and then what it has to say. If it is 0, it has to say 0. If it is 1, it has to say 1. That's it. Now let's calculate how accuracy is calculated. Okay, done. Okay, let's start with the first line. I'm taking what Malayalam. So number of classes 39 inside that Malayalam,
right? 39 different classes you have. In each class you have different samples, not a problem. So 5 batches I'm creating of size 10. So 5 different types. Yeah, I see here now. This is very interesting. You see the pair level accuracy. Over here. Not sufficient. Okay. See here. Pair label accuracy. So this is 5 and this is 5 labels, and this pair label accuracy is what 1001, and accuracy batch size is here. Wait, I'll come down. Yeah, you just see these numbers. What is the test one? 10001. When you predict it Y, you have to get the same 10001. If it is the same, 100% accuracy, right? Yes. Now, predict it. You are getting this number. I will round it off. Now what is that? What is Y? Yeah, see here. 11110. Earlier it was 10001. What is the accuracy? 20%. Only one is matching with 1. The rest all 0, it has to come, but it is saying 1. And earlier it was supposed to be 1, but it is 0. Now only 1 plus 1 character got matched. What is the accuracy?
20.
5. 1 divided by 5. It is 20%. Right? Are you getting?
Yes.
Yes. See here. And what is the accuracy? I see here 20. 0.20% accuracy. Likewise, I create what 5 different size types, and finally we see the average accuracy. Ide tara madalasthe. ಏನು ಇಲ್ಲ. Go back again. See here. Now I got different set now. The different set. What is the pair? 11010. I have to get this number 11010. But let me see what I get. And finally you see the result. Gone. 0.6. Yeah, you got some number. Good number. Right? Accuracy is what? 60%. And again you do it. First agar. So what is the average accuracy? Average accuracy, mean accuracy divided by that, it is something like 6. Average is 16. Yeah, 16%. That's it. So the problem here is that what? You have trained only number of iterations 10. If you go about 10,000 or something like that, obviously what? Your accuracy may reach 90% or something. That's it. Is that clear? Any doubts with respect to code, please let me know. And this is quite available in what MATLAB 2022 version. You have to download MATLAB 2022 version, and you have 1 month trial version. You install, you learn, and finally, if you have what rich enough to what buy that software, so probably you can buy. Right?
Or build our own.
Yeah, otherwise you build it. But anyhow, this is what I do believe that this is a really very good source for you to what understand more with respect to one-shot learning. How exactly it works. And you can what now what you have to do is that face database ಇಟ್ಕೊಳ್ಳಿ ಬಂಗಾಲಿ ಏನತ್ರ ಇದೆಯಲ್ಲ ಅದಕ್ಕೆ ನಿಮ್ದು ಇದನ್ನ ಹಾಕಿ ಇನ್ನೊಂದು ಡೇಟಾಬೇಸ್ ಇಟ್ಟು ಮಲಯಾಳಂ ಅಂತ ಇನ್ನೊಂದು ಜಾಗಕ್ಕೆ ಇನ್ನೊಂದು ಫೇಸ್ ಇದು ಮಾಡಿ ನೋಡಿ ಎಷ್ಟು ಬರ್ತದೆ ಅಷ್ಟೇ.
Does it handle the data imbalances?
100?
Data imbalances. If so, the
Imbalances.
data is imbalanced.
What is that? It doesn't make any sense.
I'm
You are
just
taking
saying
only
more
pairwise,
bias.
right? You are taking pairwise.
It won't get any
It really doesn't come with respect to imbalance. You are taking pairwise and you are training the model.
Probably there might be shortage in some class will be having this.
ಆ ಥರದ್ದು ಬರೋದೇ ಇಲ್ವಲ್ಲ ನಿಮ್ಗೆ. ಏನೋ ಒಂದು ಕ್ಲಾಸ್ ಇದೆ, ಇದ್ರಲ್ಲಿ ಇರೋದು ಇಷ್ಟೇ ಸ್ಯಾಂಪಲ್ಲು, ಅದಕ್ಕೆ ಲರ್ನ್ ಮಾಡಿ ಇಟ್ಕೊಳ್ಳಿ ಅಷ್ಟೇ. ನಾನೇನು ಹೇಳೋದು ಅಂತಂದರೆ, ನಿಮ್ಮದು ಒಂದು ಅಪ್ಲಿಕೇಶನ್ಗೆ ಡೋಂಟ್ ಗೋ ಇನ್ ದಿ ಸೇಮ್ ಲೈಕ್ ಸೈನೀಸ್ ನೆಟ್ವರ್ಕ್, ಲೈಕ್ ನೀವು ನೆಟ್ವರ್ಕ್ CNN ಅದು ಇದೆಲ್ಲ ಮಾಡಕ್ಕೆ ಹೋಗಿ ಬೇರೆ ಥರ ಏನಾದ್ರು ಮಾಡಿ ನಾರ್ಮಲ್ ಫೀಚರ್ಸನ್ನ ಎಕ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡಿಬಿಟ್ಟು ಸಿಮಿಲಾರಿಟಿನ ಕಂಪೇರ್ ಮಾಡಿಬಿಟ್ಟು ಆಮೇಲೆ ಏನಾದ್ರು ಒಂದು ಥ್ರೆಶೋಲ್ಡ್ ಇಟ್ಕೊಂಡು ಮಾಡಿಬಿಟ್ಟು ಫೈನಲಿ ಇದನ್ನ ಮಾಡಿ ಟೆಸ್ಟ್ ಮಾಡಿ ಆಗುತ್ತಲ್ಲ. ನೀವು ಕನ್ವಲ್ಯೂಷನ್ ನ್ಯೂರಲ್ ನೆಟ್ವರ್ಕ್ ಹೋಗ್ಬೇಡಿ ಅಷ್ಟೇ. ಕನ್ವಲ್ಯೂಷನ್ ನ್ಯೂರಲ್ ನೆಟ್ವರ್ಕ್ ಹೋದ್ರೆ ನೀವು ಪುನಃ ಟೈಮ್ ಜಾಸ್ತಿ ತಗೊಳುತ್ತೆ. ನಾನೇನು ಹೇಳೋದು, ಸಿಂಪಲ್ ನ್ಯೂರಲ್ ನೆಟ್ವರ್ಕ್ ಅಪ್ರೋಚಸ್ ಯಾವುದು GRNN PNN ಆ ಥರದ್ದು ಮಾಡಿಬಿಟ್ಟು ನೀವೇನು ಮಾಡಿ ಫೀಚರ್ಸ್ ಎಕ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡಿ ಸಿಮಿಲಾರಿಟಿ ಮಾಡ್ಬಿಟ್ಟು ಇದು ಮಾಡಿ ಟ್ರೈನ್ ಟೆಸ್ಟಿಂಗ್ ಅಲ್ಲಿ ಸೇಮ್ ಅದನ್ನೇ ಕೊಡಿ, ವೆಯ್ಟ್ಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿರ್ತಾನೆ, ನೋಡಿ ಸಿಮಿಲರ್ ಇದು ಅಂತ ಹೇಳೋದು ಅಷ್ಟೇ. Actually, the thing is that very less people are working in this line. Very, very less. If you have a database and if you have knowledge, every day you can publish paper. Every day you can publish paper.
Especially in handwritten signature, as we know and Guru sir said, for bank we give only 4 or 5 samples.
ಅಷ್ಟೇ ಅದನ್ನೇ ಇಟ್ಕೊಳ್ಳಿ. ನಿಮಗೆ ಸಪೋರ್ಟ್ ಸೆಟ್ ಅಷ್ಟೇ.
ಸಪೋರ್ಟ್
ಸೆಟ್. ನಿಮಗೆ ಕ್ವೈರಿ ನೀವು ಸೈನ್ ಮಾಡಿದ್ದು 3 ಜೊತೆ ಕಂಪೇರ್ ಮಾಡಬೇಕು. You check with that and finally say whether it is a genuine or not. Ask a verification.
So in occluded phases also, the occlusion comes in a different ways, not in a static function like for the.
Ma'am, any recognition obviously you can easily work. Any recognition, what task, something like character, face, object, whichever application you mention, name, and obviously you can try with what starter future. ಇದು ಏನೋ ಮಾಸ್ಕ್ ಅಂಡ್ ಅನ್ಮಾಸ್ಕ್ ಅಂತ ನೀವು ಹೇಳ್ತೀರಲ್ಲ, ನೀವೇನು ಮಾಡ್ತೀರಾ? ಈಗ ಸಿಂಗಾಪುರಲ್ಲಿ ಇದು ಮೊನ್ನೆ ಕೋವಿಡ್ ನಡಿಬೇಕಾದ್ರೆ ಸರ್ ಹೇಳ್ತಾ ಇದ್ರಲ್ಲ, ಅದೇ ಒಂದು ಎಕ್ಸಾಂಪಲ್. ವಾಟ್ ಹ್ಯಾಪನ್ ಲೈಕ್ ಇನ್ ವೆಸ್ಟರ್ನ್ ಕಂಟ್ರೀಸ್ ಅಂಡ್ ಅದರ್ ಇದರಲ್ಲಿ ಯು ಶುಡ್ ನಾಟ್ ಕನ್ಸ್ಟೆಂಟ್ ದೆಮ್. ಕನ್ಸ್ಟೆಂಟ್ ಎನ್ವೈರನ್ಮೆಂಟ್ ಅಲ್ಲಿ ಬಿಡಂಗೆ ಇಲ್ಲ. ಅನ್ಕನ್ಸ್ಟೆಂಟ್ ಎನ್ವೈರನ್ಮೆಂಟ್ ಅಂದ್ರೆ ಸುಮ್ಮನೆ ಅವ್ನು ಎಟ್ಕೊಂಡು ಹೋಗ್ತಾ ಇರ್ತಾನೆ, ನಿಂತ್ಕೊ ಅಂತ ಹೇಳಂಗಿಲ್ಲ, ಮಾಸ್ಕ್ ತೆಗಿ ಅಂತ ಹೇಳಂಗಿಲ್ಲ. ಹಂಗೆ ಹೋಗ್ಬೇಕಾದ್ರೆ ಸೀಕ್ವೆನ್ಸ್ ಅಲ್ಲಿ ನೀವೇನು ಮಾಡಿರ್ತೀರಾ? ಎಲ್ಲ ಟ್ರೈನ್ ನಾರ್ಮಲ್ ವಿತೌಟ್ ಫೇಸ್ ಮಾಡಿರ್ತೀರಾ. ಬರ್ತಿದ್ದಂಗೆ ಏನು ಮಾಡಬೇಕು? ಇದು ಅವನೇ ಅಂತ ಹೇಳ್ಬೇಕು ಹೇಳ ಅಂತ. ಮ್ಯಾಮ್, ವಿಚ್ ಎವರ್ ದಿ ಅಪ್ಲಿಕೇಶನ್ ಐಮ್ ಟೆಲಿಂಗ್ ಯು, ರೆಕಗ್ನಿಷನ್ ಅಲ್ಲಿ ನಿಮ್ಗೆ ಏನೇ ಒಂಥರ ಇತ್ತು ಅಂತಂದ್ರೆ ಯು ಕ್ಯಾನ್ ಯೂಸ್ ಇಟ್. Like only thing is that you have to see to it like whether it suits what working with one shot or few shot learning and correct and work you take time application and but obviously for face recognition and character recognition people are working fine. ನಮಗೆ ಎಲ್ಲಿ ಅಂತಂದ್ರೆ ಇದು ಹೆಲ್ಪ್ ಆಗೋದು EEG ಸಿಗ್ನಲ್ಸ್ ಮತ್ತೆ ಮೆಡಿಕಲ್ ರಿಲೇಟೆಡ್. ನಿಮಗೆ ವೆರಿ ಲಿಮಿಟೆಡ್, ಬರೀ ಒಂದು 5-6 ಇದಿರುತ್ತೆ ಸಿಗ್ನಲ್ಸ್ ಇರುತ್ತೆ. ಅವಾಗ ನೀವು ಏನು ಮಾಡ್ತೀರಾ? ಸುಮ್ಮನೆ ಎಷ್ಟೊಂದು ಬೇರೆ ಅನ್ನೋದು ಸುಮ್ಮನೆ ಕ್ಲಾಸಸ್ ಏನೋ ಇದೆ, ಸುಮ್ಮನೆ ರೂಲ್ ಟ್ರೈನಿಂಗ್ and finally whenever you have some sort of signal with very less time, then you go for a testing. Actually, we can produce good numbers of papers actually, I'm telling you, and know what conferences really reject if you have a title, few shot or one shot learning, and no journal really what rejects at the first time. This is what unmature field in what machine learning, and of course, it's another subfield of what machine learning is, a few shot learning or a one shot. The only thing is that you have to understand first and the things, and then you have to. That's it. Any other thing? Otherwise.
So you share the PPT, sir?
Yeah, we do. We also share code. Everything we take laptop. New one I will give, old one I will not. Old one can produce 10 PhDs. That many code is there. Okay.
Sir, actually, ಮೊಬೈಲ್ ಲೈವ್ ಡಿವೈಸನ್ನ ಯೂಸ್ ಮಾಡಿ ಮಾಡೋಣ ಅಂತ ಆಲ್ಮೋಸ್ಟ್ ಒಂದು ಪೇಪರ್ ಆಗಿದ್ದೇನೆ. ಬಟ್ ಒನ್ ಶಾಟ್ ಲರ್ನಿಂಗ್ ನಾನು
ಅದೇ ಹೇಳಿದ್ದು ಅಪ್ಲಿಕೇಶನ್ ಅಲ್ಲಿ ಏನು ರೆಕಗ್ನಿಷನ್ ಆ ಥರ ಸಿಮಿಲಾರಿಟಿ ಆ ಥರ ಚೆಕ್ ಮಾಡೋದೇನಾಗಿದೆ ಅಂತ ನೋಡಿ.
Rosy or not?
Yes.
Yeah, only two status.
So if it is closed, then what it has to say, it is a
Threshold need to be set for
same thing. It's a problem. You have to tell whether it's a drowsy or not. Given what face images are. Yes, you can do it. Any classification problem, as I mentioned, it can do.
Especially video.
544 classes.
So whichever, what is the size, you don't worry about that one, right?
What happened was, without pre-processing, I was training bird images. I was getting very poor accuracy. So without
What is the size of your class?
544 classes.
545? 544 classes. That many birds you have. That many birds you have. In each class, how many samples you have?
Minimum 200, 150 to 200.
Okay. Better what you try with traditional neural network approaches like GRNN or PNN. If it really does not work, as I mentioned, like deep learning model, you can also try. Another good thing, yeah, you try with traditional neural network model, like PNN, GRNN, and something like that you have. And all those codes are available. If you just mail me, I can share those codes. That is fine. Initially, you see how the things are happening. Then what you do is that you go for a deep learning model. And then what you do, again, if you get good accuracy, you stop. Or otherwise, if you want to see what different learning techniques, especially with one-shot learning, you can also experiment. What you do there, like you have 500 classes, 300 classes you train, remaining 200 classes you can keep for what? Testing. And then with many one shot or a few shot, you can just see it, and then you can say you can see the accuracy.
Sir, if I take 2 bird images, can I use Siamese network to?
Yeah, that is what I'm telling you. Take 2 bird images and say whether it is similar or not. That is what your problem, right? That's done.
Sir, is there need for pre-processing before?
See, neural network doesn't require anything. Convolution neural network doesn't require anything. Raw image you just throw. Automatically, without any pre-processing, it would work. It extracts its own features and finally it works.
Sir, the thing is, if a bird is hidden and there is a complex background.
No, that and all you need to do it and then you send.
See, two ways you can do it. One with segmentation, proper region and region of interest you can show. Or otherwise simply throwing an image and finally machine understands and finally it is. See,
so segmentation methods,
many tree graph algorithm, graph learning based algorithms are very good, gives a very good result. Or a Gaussian mixture model for that matter is also a good for segmentation. Gaussian mixture model, hidden Markov random fields, Markov random fields.
What's the method?
Also, it's like very difficult, like thresholding, but black and white you will get. That's only 2 classes you will get. But normally what happens, like Gaussian mixture model K-means algorithms ಎಲ್ಲ work ಮಾಡುತ್ತೆ. More than 2 classes ಇಟ್ಕೋಬೇಕು. 3 or 4 different classes ಅಂತ ಇಟ್ಕೊಂಡಾಗ then region of interest ನ ನೀವು ಈಸಿಯಾಗಿ find out ಮಾಡಬಹುದು.
So I thought of using tools like YOLO and all, but I don't know, will it be a contribution?
Obviously, it will not be a contribution, right? People are already done and you are using and then this is how PhDs are coming. See, that is why contribution ಏನಿರಬೇಕು ಅಂತಂದ್ರೆ ಇಲ್ಲ ನೀವು ಯಾವ್ದಾದ್ರು ಹೊಸದಾಗಿ ಸೆಗ್ಮೆಂಟೇಷನ್ ಅಲ್ಗಾರಿದಮ್ ಯೂಸ್ ಮಾಡಬೇಕು ಇಲ್ಲ ನೀವು ಫೀಚರ್ಸ್ ಏನಾದ್ರು ಎಕ್ಸ್ಟ್ರಾಕ್ಟ್ ಯೂಸ್ ಮಾಡಬೇಕು ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ ಡೋಂಟ್ ವರಿ ಅಬೌಟ್ ದಿ ಪ್ರಾಬ್ಲಮ್ ಬಟ್ ಆಲ್ಸೋ ಟ್ರೈ ವಿತ್ ಆಲ್ ದಿಸ್ ಒನ್ ಶಾಟ್ ಲರ್ನಿಂಗ್ ಆರ್ ಫ್ಯೂ ಶಾಟ್ ಲರ್ನಿಂಗ್ ಇಟ್ ಗಿವ್ಸ್ ಯು a sort of
So first I have to try this for segmentation. After segmenting, I have to use it for
region of interest. One idrun ಮಾಡಿ without region of interest simply a raw images you can give and you can also test it.
both.